Hello guys. Good morning. Oh, not good morning. Good evening. Good evening. Good evening, everyone. Am I audible? Hello, children. Hi, guys. Hi, Prakash. అయ్యో எங்கடா ஜாயின் பண்ணுங்க சீக்கிரமா பார்க்கட்டும். I'm be excited. I'm excited, but I am feeling like a kind of a dizziness. Manikandan. Hi. Hi, Manikandan. I'm not basically belong to completely Tamil, but I belong to the Malayali only, but I know Tamil. Hi, Joshua. Prakash, you were not there in yesterday's class, right? Prakash, you were not in the day before yesterday's class, right, Prakash? Good evening, Joshua. சீக்கிரமா வாங்கடா guys. நம்ம இன்னைக்கு ஐசோமெரிசம் மிச்சம் இருக்கிறது மொத்தமா எடுக்க போறோம், and we are going to start with the hydrocarbons also. Hydrocarbons, I guess probably I will be completing it, or else I required like Saturday, not day after tomorrow, we will be completing with the hydrocarbons and the haloalkanes and haloarenes also. ஸோ வெல்கம் பேக் டு வேதாந்து நீட் வெற்றி சேனல். நான் உங்களோட மாஸ்டர் டீச்சர் அனகா. ஸோ இன்னைக்கு நம்ம வந்து we were doing the marathon series which was starting from the organic chemistry and we done with the basics of the organic chemistry. அதில் வந்து isomerism தான் இப்போ நம்ம கம்ப்ளீட் பண்ண போகிறோம். Actually I was supposed to start with the isomerism first. I was supposed to start with the isomerism first, but I had done a one shot on that, so I thought that that is enough. But actually in depth பார்க்கும்போது அது பத்தாது. ஸோ அதனால தான் நான் isomerism ஸ்டார்ட் பண்ணேன். ஸோ இன்னைக்கு நம்ம isomerism முடிக்க போகிறோம். ஸோ isomerism முடிச்சிட்டோம். Then we will be discussing about, we have done with the GOC1, GOC2, IPS, IUPAC nomenclature, everything. Now we will be starting with the isomerism. We will be done. It will be over by today. And today itself we will be start with the hydrocarbons also. Okay. Same molecular formula, different structural formula. That is the isomerism only, but we have to study a little more in depth now. That is not enough. Okay, so நம்ம வந்து isomerismத்துல நம்ம வந்து we were discussing about, we done with the D and L configurations. We were discussed about the R and S எப்படி வருது அதெல்லாமே நம்ம நேற்று டிஸ்கஸ் பண்ணிட்டு இருந்தோம். ஆமா தானே? யூ ரிமெம்பர் மை டியர் ஸ்டூடெண்ட்ஸ்? isomerismத்துல நம்ம டிஸ்கஸ் பண்ணிட்டு இருந்தது. ஸோ இனி நம்ம வந்து எடுக்க போறது என்னன்னா, we are going to discuss about the enantiomers. Do you know what is enantiomer, student? Any idea about the one enantiomers? enantiomers என்னன்னு தெரியுமா பசங்களா? ஏதாவது ஐடியா இருக்கு enantiomers பத்தி? கேள்விப்பட்டிருக்கீங்களா எங்கேயாவது enantiomers? மேம் நான் கேள்விப்பட்டதே இல்லை மேம் enantiomers என்னன்னு. Yeah, I will, sure. I will do a recap. I will do a recap. Just a second. Just give me a second. Give me a second. I'll do the recap. One second. Okay, so we were starting with the isomerism has been divided into two. What are the two different types of the isomerism? Yes, 12th லயும் இருக்கு, 11th லயும் இருக்கு. So isomerism was the structural isomerism, was the stereo isomerism, was the structural isomerism means we can say that they have different they will be having different same molecular formula but different structural formula, right? That is basically spatial arrangements. இல்லைனா structure spatial arrangements or the stereo isomerism structures different இருக்கும். So அதுதான் என்ன சொல்றது, structural isomerism சொல்றது. அதில் தான் நம்ம செயின் ஐசோமரிசம் படித்தோம், நம்ம பொசிஷன் ஐசோமரிசம் படித்தோம், ஃபங்க்ஷனல் குரூப், ரிங் செயின், மெட்டாமரிசம், டாட்டோமரிசம் எல்லாமே அதை தான் படித்தோம் ஸ்ட்ரக்சரில். அதுக்கப்புறம் we are going to discuss, we done with the discussion of the stereo isomerism. Stereo isomerism சொல்றது என்னன்னா, அவங்களோட ஸ்பேஷியல் அரேஞ்ச்மெண்ட்ஸ். ஃபார் எக்ஸாம்பிள், இஃப் திஸ் இஸ் ஏ காம்பவுண்ட், இந்த காம்பவுண்டோட மோலிகுலர் ஃபார்முலா, இது ரெண்டு காம்பவுண்ட் எடுக்கிறேன்னா, இஃப் யூ ஆர் டேக்கிங் டூ காம்பவுண்ட்ஸ், while we are checking that compounds, அவங்களோட மோலிகுலர் ஃபார்முலா சேமாக இருக்கும். பட் ஹவு தே ஸ்பேஷியலி அரேஞ்ச்ட், அவங்க எப்படி அரேஞ்ச் பண்ணியிருக்காங்க இந்த ரெண்டு மாலிக்யூல்ஸ், that will be different. So that's how the stereoisomerism works, and according to that there are two types of isomerism. One is the configurational isomerism and one is the conformational isomerism. Okay, configurational isomerism சொல்றது, you have the geometrical isomerism and optical isomerism. configurational isomerismல அடுத்தது வந்து கன்ஃபர்மேஷனல் ஐசோமரிசம் பற்றி தான் நம்ம டிஸ்கஸ் பண்ணிட்டோம். ஸோ நம்ம வந்து ஜாமெட்ரிக்கல் ஐசோமரிசத்தை பற்றி வி டிஸ்கஸ்ட் அபவுட். ஓகே, ஜாமெட்ரிக்கல் ஐசோமரிசத்தில் எப்படி வந்து ஆல்கேன்ஸில் இருக்கும், அது வந்து டபுள் பாண்ட் வரும்போது ஜாமெட்ரிக்கல் ஐசோமரிசம் இருக்கும், அதெல்லாமே நம்ம டிஸ்கஸ் பண்ணிட்டோம். எப்படி வந்து அதை கண்டுபிடிக்கிறது இதெல்லாமே நம்ம டிஸ்கஸ் பண்ணிட்டோம். இனி ஜாமெட்ரிக்கல் ஐசோமரிசம் முடிச்சதுக்கு அப்புறம் தான் ஆப்டிக்கல் ஐசோமரிசத்தில் வருது. ஆப்டிக்கல் ஐசோமரிசம் வந்து பிளெயின் பாலரைஸ்டு லைட்டை வந்து டெக்ஸ்ட்ரோ லீவோ கேட்டகரியில் வந்து லெஃப்ட் அண்ட் ரைட் என்ன சொல்கிற மாதிரி they can actually, the plane polarized light can be deflected into dextral and levo deflections. அதுல வந்து we discussed about the chiral center, point of symmetry, center of symmetry, இதெல்லாமே நம்ம டிஸ்கஸ் பண்ணிட்டோம். கரெக்ட்? Then we discussed about the wedge and fissure, ஒரு ஆப்டிக்கல் ஐசோமரிசத்தில் வர காம்பவுண்ட்ஸை வந்து எப்படி நம்ம வந்து ரெப்ரசென்ட் பண்ணுறது. அதில் வெஜ் ஃபார்முலா இருக்குது, வெஜ் அண்ட் டேஷ் ஃபார்முலா இருக்குது, அண்ட் யூ ஹேவ் யோர் ஃபிஷர் ப்ரொஜெக்ஷன் ஃபார்முலா ஆல்சோ. ஃபிஷர் ப்ரொஜெக்ஷன் ஃபார்முலேருந்து வெஜ் ஃபார்முலேக்கு எப்படி பண்ணுறது, வெஜ் ஃபார்முலேருந்து ஃபிஷர் ப்ரொஜெக்ஷன் ஃபார்முலேக்கு எப்படி பண்ணுறது, ஆர் அண்ட் எஸ் கான்ஃபிகரேஷன் என்னது, இது எல்லாமே நம்ம டிஸ்கஸ் பண்ணிட்டோம். இனி நம்ம ஆப்டிக்கல் ஐசோமரிசத்தில் enantiomers சொல்லிட்டு இருக்கிற ஒரு டாபிக் பற்றி தான் டிஸ்கஸ் பண்ண போகிறோம். we are going to discuss about the enantiomers. Listen carefully here, children. Enantiomers. Okay guys, no, something happened now. 1 second. we are going to discuss about the enantiomers. Enantiomers. Okay, enantiomers சொல்றது they are optically active. The compound which have same molecular formula, they have same structure also. This is not STO structure. Okay, this is STR structure also, and but non-superimposable mirror image. Non-superimposable mirror image of each other is called as the enantiomers, which means we can say that the enantiomers are optically active. அவங்க என்னதான் இருக்கும் பசங்களா? They are, as I told you, they are optically active. அவங்க optically active இருக்கிற compounds என்ன இருக்கும்? They will be having the dextro and levo configuration. What are the things? Enantiomer சொல்றது எப்படி இருக்கும்? அவங்களோட molecular formula சேமா இருக்கலாம், அவங்களோட structure சேமா இருக்கலாம், and they are non-superimposable and they are optically active also. That's why they have D and L configurations. So in the NCERT they are telling, like NCERT அப்பவே படிச்சு போய்க்கோங்க, enantiomers have same physical properties like melting point, boiling point. They do have the same refracting index, etc. But what happens, what is different in their behavior towards the plain polarized light? That is actually the difference. They will be having different spatial arrangement, and there is a difference for that. So because of that only there is a difference in their behavior. So that is actually called as the enantiomers. Now I will give you an example. Student, don't worry, I will give you an example, then it will be much easier for you. Listen carefully. So this is a compound. ஈஸியாக புரிஞ்சுக்கலாம், நல்லா கவனமாக இருந்தால் மட்டும் போதும். ஈஸியாக புரிஞ்சுக்கலாம், இதெல்லாம் எந்த டிஃபிகல்ட்டி இல்லை. Okay, these are the compounds which is given for you, children. Now listen, find out whether it is an R or S configuration. How will you find out whether it is an R or no? R or S? You know that whenever the particular least priority group LPG, that is least priority group, they are in the vertical position. They are in the vertical position means clockwise இருக்கும்போது we will be considering it as R, anti-clockwise இருக்கும்போது we will be considering it as S. Okay, this is the one which we have discussed. Now அதோட ஆப்போசிட்டா இருக்கும், இல்லைன்னா அதோட ஆப்போசிட்டா இருக்கும். இப்போ யோசிச்சுக்கோங்க, நல்லா கவனமா இருந்துக்கோங்க. So you have OH is the which is one. First of all, write down the compounds. This is your carbon chain, correct? Now OH1, this is your 2, correct? This is 2, this is 3, right? So which means இப்படிதான் போயிட்டு இருக்கு. இப்படி போயிட்டு இருக்குன்னா this is supposed to be S. ஆனா least priority group is hydrogen. Hydrogen has the least atomic number, so hydrogen is the least priority group. Least priority group vertical இருந்தா மட்டும்தான் anti clockwise ஆகும்போது S கன்சிடர் பண்ணணும், இல்லைன்னா அதோட ஆப்போசிட் தான் கன்சிடர் பண்ணணும். So hydrogen is on the horizontal line now, so we supposed to be S, but since hydrogen is a vertical one, we have to choose it as R. Clear everyone? Clear? So இது வந்து least priority group vertical இருந்தது. இதே வந்து இங்க இருந்தேனா ஹைட்ரஜன் வந்து எங்கேயாவது இருந்திருந்தேனா it's wrong, it's different. Clear everyone? Now here ஒரு நிமிஷம் பசங்களா, அங்க தப்பா எழுதிருக்கு. So this is like this. இப்படி வருது, which it is supposed to be R actually. ஏன்னா கிளாக் வைஸ் தான் வருது. ஆனால் ஹைட்ரஜன் வந்து வெர்டிக்கல் பொசிஷன் இருக்கிறதுனால நாட் ஆர், இட் இஸ் எஸ். ஓகே, ஸோ நவ் யூ கேன் see that while we are checking the configuration of this is R and this is S. So whenever there is R and S, these two are enantiomers. These two are enantiomers for the both, and they will be having non-superimposable mirror image. They will be having what, my dear students? They will be having non-superimposable mirror image. Clear, everyone? Clear? Now look to this configuration, children. Look to this configuration. You will be having one here. Okay, you will be having 1 2 3, which means like this it will be. So we expected that it should be in the R config, it should be in the S configuration because it is like anti-clockwise, right? We expected that it should be in the, one second, children. We expected that it should be in the particular S configuration, but what happens here is this is supposed to be S, but hydrogen is in the horizontal position, it's not in the vertical position, so it's not S, it will be R. Okay, so now here also 1 2 3, which means like this is the one, right? This is the one means which is also, that is also we are supposed to be S, but hydrogen is in the vertical position means it is R, opposite. So these two groups are, listen carefully, these two groups are your identical. These, because they have same configuration now, so they are identical. Clear, everyone? Clear? So this is the difference between the particular enantiomers and this identical. Now look to this, children. You can understand from this, this is 1, this is 2. So this will be like this, right? It will be going like this. This is also another example for the enantiomers. Listen carefully. This is your 1, this is your 2, 3. So hydrogen should be in the particular, if it is a formula, this is wet dash formula lo kudukranga, hydrogen vanda eppadi irukano, dash la da irukano. So this is correct only. So 1 2 3, which means இப்படி தான் வருது. இப்படி வரும்போது this is R only, not S, because why it is not S? wedge dash formula வரும்போது ஹைட்ரஜன் வந்து vertical lines, ஹைட்ரஜன் வந்து dash linesல தான் இருக்கணும். Okay, so this is hydrogen the dash line only. Now இங்க வந்து பாத்தீங்கன்னா you can see that 1 2 3, which is, this is also R. So these two are identical. Now while connecting to this, you can see that 1 2 3, which means இப்படி போறாங்க. இப்படி போகும்போது நம்ம என்ன நினைக்கும், R தான் வேணும், ஆனால் ஹைட்ரஜன் should be here. So if hydrogen is not there, it should be opposite to that, S ஆயிடும். Okay, so now this இங்க வந்து பார்த்தீங்கன்னா 1 2 3, so which is like R only, and hydrogen is in the particular dash formula, so the R only. So now we can see that this is R, this is R, and this is SR, which means these three are, first one, second one, and fourth one. First one, second one, and the fourth one are identical, and first and second is identical. First and third is enantiomers. These both one na இதுவும் வந்து உங்களுக்கு என்ன இருக்கும், enantiomers-ஆ இருக்கும். அதே மாதிரி செகண்ட் ஒன்னும் தேர்ட் ஒன்னும் என்னதான் இருக்கு, enantiomers-ஆ இருக்கும், because they are opposite to each other. Clear? Clear, everyone? Clear? Shall I give you another example also? Now just listen. டெக்ஸ்டில் இல்லாமல் இன்னொரு எக்ஸாம்பிள் கொடுக்குறேன். Find out the enantiomers and find out the identical ones here. Which are the identical one and which are the enantiomers? Tell me. My dear students, those who are watching the video, please do tell me. சொல்லுங்க பசங்களா, இதுல இது enantiomers branch-ஆ இருக்கும், இது வந்து diastereomers-ஆ, I mean identical-ஆ இருக்கும். சொல்லுங்க பாப்போம். How will you find out? See, whenever there is wedge-dash formula, hydrogen is in the dotted line, which means dash lines. அப்படின்னா இது வந்து R-ஆ இருக்கும், இப்படி போகிறேன்னா இது வந்து S-ஆ இருக்கும், clockwise anti-clockwise. Okay, இல்லைன்னா opposite-ஆ இருக்கும். So listen carefully. We have to number it 1, 2, 3, which means this will be the going. Right, this will be going means how it is going? R. Since hydrogen is in the dash formula, there is no change, it will be R. Clear? Now look into this. 1, 2, 3 இப்படி போகிறேன்னு வச்சுக்கோங்களேன், which means it is S, supposed to be S. What is anti-clockwise? If it is hydrogen is in the vertical line, I mean hydrogen is in the dash lines, right? But hydrogen is not in the dash line, so whatever is the opposite to that, it will be R. Clear? Now here 1, 2, 3 இது இப்படிதான் போகுது, which means it is supposed to be S, anti-clockwise, but hydrogen is not in the dash line. If hydrogen is not in the dash line means we are considered as a R. Clear? Those all are R. Okay, now another one more example. This is 1, this is 2, this is 3, which means it's going like this. It's supposed to be R, but hydrogen is not in the vertical line, so it is S. Clear everyone? Now tell me which are enantiomers and which are identical. We can say that A, B, C are identical. Am I correct? Because R. A and D are enantiomers. Yeah, we can write it like this, my dear students. A bar, B bar, C, D. 2D. They are enantiomers. Clear? R means it's a kind of like we can say that it's a R and S configuration. R means if the particular arrangement is going like it is like anti-clockwise போகிறேன்னா R configuration-ஆ இருக்கும், clockwise போகிறேன்னா R configuration-ஆ இருக்கும், anti-clockwise போகிறேன்னா S configuration-ஆ இருக்கும். அது எப்போனா ஹைட்ரஜன் வந்து இந்த டேஷ் ஃபார்மில் இருக்கும்போது, இப்போ இங்கே பார்த்தீங்கன்னா ஹைட்ரஜன் இஸ் டேஷ் இந்த டேஷ் ஃபார்ம். இப்போ நம்ம வந்து அதை நம்பர் பண்ணுறேன்னா you know that how to ciprol is there, right? Ciprol எப்படி இருக்கும்? Ciprol, what is ciprol, children, my dear students? Tell me what is ciprol. Ciprol சொல்றது we have to give importance to the first of all which is having more atomic number. So இதில் எல்லாத்துலேயுமே பார்க்கும்போது இது கார்பன், இது ஹைட்ரஜன், ஆக்சிஜன். So oxygen is a more one. Now next between these two, what we can say that this is also carbon, this is also carbon. Both have the atomic number of 6. Now we have to check for the next atom, which is oxygen. And C double bond O means it is having more bond. So this will be the second one. Next one is third, then fourth. So 1, 2, 3. This is the order. We don't want to consider fourth. This is the order, which means R is the order. Since hydrogen is in the particular dash order can the change R, we can consolidate it as an R. Now inga வந்து பாத்தீங்கன்னா நம்ம order வந்து பாக்கும்போது it is like anti-clockwise. This is the order it is going. So we are supposed to be S. ஆனா இங்க என்ன ஆகுறேன்னா ஹைட்ரஜன் வந்து எங்க இருக்கு? டேஷ்ல இல்ல, இந்த லைன்ஸ்ல இல்ல, they are in the wedge form. So நேரா உல்டா நம்ம எழுதணும். S ஆ இருந்தாலும் we have to write it in the R form. Clear everyone? So this is how this works. Okay, I hope it is clear, children. Now we are going to look about the diastereomers. Diastereomers are very important. See, they are the stereomers which are not mirror image of each other. They are not the mirror image. So they may GI or OI. OI means geometrical isomerism வேணும்னா follow பண்ணலாம், இல்ல optical isomerism காமிக்கலாம். They do have different physical properties. Diastereomers சொல்றது, they are different physical property and they are not the mirror image also. So this is actually diastereomers because they are symmetrical ones, and this is cis and this is trans, right? This is cis and this is trans. So they are actually an example for the diastereomers. Any diastereomers eppadi kaamikalana kandupidikalana, listen carefully, this is very important. For example, you have the two molecules. இது வந்து ஒரு காம்பவுண்ட் இப்படி இருக்குது, இது இன்னொரு காம்பவுண்ட். ஓகே, ஒரு காம்பவுண்ட்லேயே வந்து பார்த்தீங்கன்னா யூ ஹாவ் போத் ஆர் போத் எஸ். அதே மாதிரி ரெண்டு காம்பவுண்ட்ஸ் இருக்கிற மாதிரி ஃபிஷர் ப்ரொஜெக்ஷன் ஃபார்முலா இந்த மாதிரி. இதில் ஒரு கார்பன் ஆறா இருக்குது, இன்னொரு கார்பன் ஆறா இருக்குது. இவங்க ஒரு கார்பன் ஆறா இருக்குது, இந்த ஒரு கார்பன் ஆறா இருக்குது. ஸோ இந்த மாதிரி கேசஸ்ல எல்லாம் எல்லாமே சேமாக இருக்கிற மாதிரி இருந்தேன்னா தே ஆர் ஆக்சுவலி ஐடென்டிக்கல். ஓகே, தே ஆர் ஆக்சுவலி ஐடென்டிக்கல். ஐ வில் டெல் யூ an example for you. See, இந்த மாதிரி கேசஸ்ல நான் ஒரு எக்ஸாம்பிளாக உங்களுக்கு கொடுக்குறேன். Listen carefully, children. For example, இப்படி இருக்குன்னு வச்சுக்கோங்களேன். This is your 1 2 3. This is going to be your R. Am I correct? இதுதான் உங்களோட ஆரா இருக்கும். ஆமா தானே? இது ஆர் கான்ஃபிகரேஷன் தானே? இதே வந்து இன்னொன்று இடத்துல, ஃபார் எக்ஸாம்பிள், சப்போஸ் யூ ஹாவ் இது ஒன்று, I mean, this is not one. 1 2 3, which means இது எப்படி இருக்கு, இப்படி தான் வருது, which means this is also R. So these two are identical. So R ரெண்டு காம்பவுண்ட்ஸ்ல R வரேனா, இல்லை ரெண்டு காம்பவுண்ட்ல SS வரேனா, இல்லை இதே மாதிரி ரெண்டு காம்பவுண்ட்ஸ் கொடுத்துட்டு they have 1 2 3 4 carbon together. ஸோ அந்த மாதிரி சுச்சுவேஷன்ல இங்கேயும் R வருது, இங்கேயும் R வருது. இன்னொரு காம்பவுண்ட்ல வந்து இங்கேயும் R வருது, இங்கேயும் R வருது. So this is actually an example for the identical. If not that is the case, I will give you another example. For example, I'll give you அதான் ஐடென்டிக்கல் சொல்றது. ரெண்டுலுமே ஒரே மாதிரி இருக்கிற கான்ஃபிகரேஷன் வந்துருச்சுன்னா ஐடென்டிக்கல். If you have here R, okay, here also R, but you have here S and S, okay, or else you have R here, S here. Now in the other one you have S and R. If this is the configuration, which means inga R இருந்ததுல either one second ஒரு நிமிஷம். இங்கே R இருக்கு ஐடென்டிக்கல்ல. Okay, this was identical, right? This was identical. Am I right or wrong? Yes. In the identical, if we are taking, okay, if we are taking 2, in the identical, if the configuration is R, S, S, these two are called as the enantiomers. These two are called as the, not enantiomers, original diastereomers. Illa enantiomers. enantiomers. What is RR? இது RR இருக்கு, இது SR இருக்கு. ரெண்டுமே different இருக்கு. இனி இன்னொன்னு, இது RR இருக்கு, இது RR இருந்தது. This was your particular என்ன சொல்றது, identical. இந்த identicalல இருந்து listen carefully. இந்த identicalல இருந்து I'm just changing this particular R and giving S here. Okay, and also I'm changing these two R. Instead of that, I'm just giving you S and R, which means opposite side la vara madri. R S irukku, S R irukku. So this is also an example for the enantiomers. Clear? So RR SS இங்கேயும் வந்து RR இருக்கிறது, SS இருக்கிறது. மறுபடியும் இந்த Rமே நம்ம சேஞ்ச் பண்ணிட்டோம், இந்த Sமே நம்ம சேஞ்ச் பண்ணிட்டோம். இதுல இருந்து R சேஞ்ச் பண்ணிட்டோம், S கொடுத்துட்டோம். இங்க இதுல இருந்து S சேஞ்ச் பண்ணிட்டு R கொடுத்துட்டோம். So இந்த மாதிரி கான்ஃபிகரேஷன் வந்துருச்சுன்னா that is also comes under the category of the enantiomers. So this is the second category. Now you may ask that, ma'am, then what is, ma'am, this particular diastereomers? Diastereomers na, I'll tell you. Diastereom is always for the 4 carbon atoms. Okay, 4 carbon set la da diastereomers irukum. Now listen carefully, children. Listen carefully. If it is a diastereomers, okay, if it is a diastereomers, RR is there, RR is this is for something which you have discussed about the diastereomers. Adila, see RR, sorry, one second. RR. This is something which you have done with the identical. This was your identical. When they have both RR means that is identical, right? So this is what we learned. When they have the both RR means that was an identical. Now, if you have instead of both R, one R is replaced with the S. So RR is there, RS is there. So this particular one, identical la irundhu ஒரு R la S replace பண்ணிட்டேனா, they are called as diastereomers. Inge you have the SS configuration, which was identical. In the SS configuration la irundhu, if we are just replacing one S and we are giving R here, so this is also your diastereomers. Clear? This is also your diastereomers. So this is the difference between the identical enantiomers, diastereomers. Identical சொல்றது ஒன்று RR SS இல்லைன்னா RR RSS இல்லை RS SS RR SS அப்படிதான் இருக்கும் ஐடென்டிக்கல். enantiomers சொல்றது ஆறும் எஸ்ஸும் இருக்கலாம், இல்லை ரெண்டு ஆறும் ரெண்டு எஸ்ஸும் வரலாம், இல்லைன்னா ஒரு ஆறு ஒரு எஸ் ஒரு எஸ் ஒரு ஆறு ஆப்போசிட்டாக வரலாம். diastereomers வருது RR வரும், அதே மாதிரி RS வரலாம், அதே மாதிரி SS வரும், SR வரலாம். Clear everyone? Clear? Those who are watching, clear? Okay. Clear? Now comes your erythro and trio. This is basically you will be studying erythro, trio and all in your biomolecules. So we are going to talk about the erythro and trio also. Then you have your racemic mixture, resolutions, etc. Okay. Then you have your calculations of the optical isomerism. We can complete this chapter. Okay, so next one is your epimers is not there. Okay, erythro and trio. Erythro and trio means the system is applicable when molecules have two chiral center. ரெண்டு chiral center இருக்கணும். இது ஒரு chiral center, this is a one chiral center and this is another chiral center. So the molecules have two chiral center means we can consider it is having a erythro and trio. So when you're checking about what is exactly the system is, see I told you there should be two chiral center, and what happens means the 6 atoms are there now. இங்க வந்து 6 atoms இருக்கும். 1, for example, 1 2 3 4 5 6, and the 6 atoms which is attached to this two chiral center have two same and two different group. ரெண்டு same group இருக்கணும், ரெண்டு என்ன இருக்கணும், different group இருக்கணும். This is the same group, this is the same group, this is the same group, this is the different groups. So I'll tell you how it is works in easy manner. I will tell you. One second. if both same groups are on the same side, same group, same side, that is actually called as the erythrio. That is actually called as the erythrio. One second, erythrio. Okay, erythrio. Erythrio. One second, I will write it and erythrio. If two groups are on the same side, same group, same side. Okay, if it is on the different side, ரெண்டுமே வந்து டிஃப்ரெண்ட் சைடில் இருக்கிறேன்னா trio, they are on the different side means trio. Same group, different side. Okay, that is trio. Clear? Now, so when I'm telling you, I give you an example like CH3, you have the COH here. Okay, CH2, CH3 better. CH2, CH3, hydrogen, bromine. Okay, two groups are on the same side, which means erythro, erythrio. Am I correct? Erythrio. See, two groups are same, sorry, not two groups, same groups are on the same side. Now, same groups are on the different side, which means trio. Same group are on the different side, same group are on the same side, same group are on the different side. So, erythrio and trio. Clear, everyone? Clear? Now you have your meso compounds. I will delete this. You have your meso compounds. What is meso compounds? Meso compounds are it's a chiral molecule, that is, it is optically inactive molecule which is two or more chiral atom but optically inactive due to the presence of the symmetry. Meso compounds means they are optically inactive and there is no, they have the center, usually they will be having the center of, I mean it's not center of symmetry, usually they will be having plane of symmetry. So due to the presence of the plane of symmetry, they are actually optically inactive. So meso compounds are optically inactive due to the internal compensation, or we can say that due to this particular due to the particular presence of the plane of symmetry. Now, while we check this particular compounds, okay, first compound, I will just check it. Just give you some examples for the first compounds. They should have at least two chiral center. Okay, at least two or more chiral center they are telling. Now, CH3, OH, H, CH3. Here, COOH, OH, hydrogen, COOH. Now, listen carefully. You know that optically active, if they are optically active, they are optically active. They have center of symmetry. They don't have center of symmetry. If they have center of symmetry, it's usually for the cyclic compounds. Okay. Point of symmetry, they do have the point of symmetry. What happens means when we cut it together, we can fix it. See, this CH3 will be going here, this OH will be going here. So point of symmetry is there. So if they're optically active, no, since the point of symmetry is there, they are optically not active, optically inactive. Now here, optically they have chiral center, not center of symmetry. One second, what I'm writing here. Chiral center, they do have two chiral center, right? Here also two chiral center, not this one, two chiral center. They do have two chiral center. So two chiral center is there. So if there is chiral center means optical activity chances are there. Now center of symmetry is there? No. No center of symmetry also optical activity chances are there. Plane of symmetry, yes, we cut, when we cut this particular one, we can get it together, right? So plane of symmetry is possible. So since plane of symmetry should not be happen, right? So they are optically active? No, they are optically inactive. Are you getting my point, children? Are you getting my point? Optically inactive. So these are the examples for the one which is optically inactive. Now another compound which is optically active, I will give you. This is another compound. So you can say that center of chiral center is the, yes, two chiral center is the, center of symmetry is the, no center of symmetry. Plane of symmetry is the, no ma'am, plane of symmetry is not the, because when I cut it, hydrogen is in the OH position. It's not the same one, right? So plane of symmetry is also not the. So optically active, yes, they are optically active. So this is an example for that. Clear, everyone? Clear? Now, next one is your racemic mixture. Racemic mixture is nothing. It's written, it's the mixture of 50%, 50 is to 50, which means 50% of the D and L, dextro and levo. So that is actually called as the racemic mixture. When we are taking a beaker, we are adding 50% of this R, which is plus theta, and S, that is opposite, na, dextro and levo. So R and S in a particular mixture, that particular mixture is actually called as your racemic mixture. That is particularly called as the racemic mixture. So that process of making the racemic mixture by the mixing 50% of the ratio of dextro and levo. Illana, நமக்கு எப்படி சொல்றானா ஆர் ஐசோமரசத்தையும் எஸ் ஐசோமரசத்தையும் ஒட்டுக்க ஒரு பீக்கர்ல போடும்போது அங்க அந்த ஒரு பர்டிகுலர் மிக்சரை தான் என்ன சொல்றது, that is the mixture is called as the racemic mixture. So we can say that, see, you know that R will be, if R is having plus theta means, if R is having plus theta, you know, you can understand, if R is having plus theta, this will be having minus theta. So together the theta net will be equal to 0. Okay, that is also another point. So what happens means the racemation, the process of making, so that particular mixture is called as the racemic mixture. 50% of dextro and levo called as the racemic mixture. And the process தான் நம்ம என்ன சொல்றது, racemation சொல்றது. That particular process is actually called as the racemation. 50%, 50 is to 50 ratio of the dextro and levo isomers is called as the racemation. Now resolution means it is a process of separating these two one. So இவங்க ரெண்டு பேருமே செப்பரேட் பண்றதுக்குனா நம்ம என்ன சொல்லுவோம், ரெசல்யூஷன் சொல்றது. So racemic mixture means 50% of dextro, 50% of the levo, or else we can say that R and S configuration 50% we are putting into a beaker, that is actually racemic mixture. And the process are racemation சொல்றது. அதை separate பண்ற process தான் resolution சொல்றது. Okay, clear? Now there is a question, children. In a mix of 80%, in a mix of 80% butane 2-ol, which means positive means dextro butane 2-ol and levo butane 2-ol present, then enantiomer excess is. So 80% is there. See, children, they have give you the 80% and 20%. So what is enantiomer? This is excess. How much amount it is excess? 80 minus 20, which is 60%, it is excess. Clear, everyone? Clear? This is a question that they have asked it. Okay, this question, this 80 minus 20, which is 60% of which one is excess here? Plus butane 2-ol is present. This is not required for you, children. This is me. Clear, everyone? Clear? So this is all about the enantiomers, diastereomers, meso compound, and the racemic mixture. This is all about the clear enantiomers, diastereomers, and this particular racemic mixture. Clear? Not நிமிஷம். ஒரு நிமிஷம் பசங்களா. ஓகே. Okay, next one is the calculation of the number of optical isomerism. Optical isomerism ஓட calculations தான் எவ்வளோ optical isomerism இருக்கு அதோட calculations நம்ம பண்ண போகிறோம். So always remember, if that is a symmetrical compound, symmetrical compounds இருந்தனா optical active isomerism சொல்றது, which means it can be dextro and it can be levo also. So அதுன்னு சொல்றது it's always 2 raised to n. And you know that optically inactive meso compounds m சொல்றது அங்கே இருக்காது because they are unsymmetrical. Meso compounds are actually useful for the symmetrical ones. Okay, so total number of isomerism, which is a plus m, is equal to 2 raised to n. Total number of optical isomerism, which is 2 raised to n. If the compound is symmetrical, and n is odd, n means another stereoisomerism. Evlo avangaloda stereoisomerism is possible. N is the stereoisomerism, or we can say that more stereocenter, not isomerism, basically stereocenter or asymmetric carbon, everything. Okay, so that is 2 raised to n minus 1 minus 2 raised to n by 2. So optical isomerism, inactive mesomerism amount சொல்றது, that is actually 2 raised to n minus 1 by 2. In total, if we are asking about the total isomerism, means it is 2 raised to n minus 1. Now இது ஈவனா இருந்தேனா 2 raised to n minus 1, அதே வந்து if you have that is in the meso compound inactive இருந்தேனா 2 raised to n by 2 minus 1. Together we will be having 2 raised to n minus 1 plus 2 raised to n by 2 minus 1. Okay, so then n is actually in the number of chiral center and the stereomeric centers or asymmetric carbon. Now that is actually now இன்னொரு விஷயம் number of enantiomeric pairs. எவ்வளோ enantiomeric pair இருக்கு அந்த racemic mixtureலன்னு வந்து we can just solve it out by 9 by 9 a by 2. We can solve it by a by 2. Whatever is optical isomerism we are giving, that divided by 2, we will be getting the number of enantiomers pair. Okay, you don't want to do anything there. A number of enantiomers pair from this particular racemic mixture நமக்கு கிடைக்கும் 9 by x. Okay, one second. Clear everyone? Please do tell me those who are in the chat box. Now, there are some examples. I will give the examples here. Then we can do it, okay? For example, you have CH3, CH3. Okay, this is a compound, and you're supposed to find out the total number of isomerism. This is your lactic acid, children. This is your lactic acid, okay? So you're supposed to find out the total number of isomerism, and you find out the racemic mixtures also, enantiomers or racemic mixture. Try to do it, children. So you can understand that this is an unsymmetrical compound, correct? If it is an unsymmetrical compound, what was the optical isomerism? A. Optical isomerism A is equal to 2 raised to 1. What is the N here, my dear students? You can see that this is your N. This is the only chiral carbon which is there, right? Rest of the things will be having. How will you find out the chiral carbon? The valencies has to be different, filled by the different elements, right? Here the valencies has been filled by different elements. Only one is available. So 2 raised to 1, which is 2. Optical isomerism. Is there any meso compound? Is there? No. They should have, see, for the meso compound, we have already discussed that at least they should have 2 chiral center. Inga on the 2 chiral center illa. So they don't have any meso center also. So total optical isomerism is equal to 2 plus 0, which is 2. Now when you are finding out the racemic mixture நம்மளால கண்டுபிடிக்கணும் கேக்குறாங்கன்னா, you can add it 2 by 2, which is equal to 1. Only one racemic mixture is possible from this. Clear, everyone? Clear? நீட்ல வந்து நீட்லி எய்ம்ஸ்லலாம் இந்த கொஷின் கேட்பாங்க, நல்ல கவனமா படிச்சுக்கோங்க. Shall we do the next question? One more question. I'll give the questions. Try to do this. Okay, this is the first one. Then you have the tartaric acid. No. Tartaric acid is OH. There is no hydrogen here, okay, children? There is no hydrogen here. So this is the next question. One more question I will give you. This has been asked in the NEET. Okay. NEETல கேட்டிருக்காங்க. Do it. Try to do it, children. I'll give you 2 minutes. Do it. Those who are watching the video, please do it. Do it, பசங்களா பார்க்கட்டும். Try to do it, children. ஏசி போட்டால் ரொம்ப குளிராக இருக்கும், ஏசி போடலைன்னா ரொம்ப வேற இருக்கும். ஓ என்னடா இது, இப்போ ரொம்ப குளிராயிடுச்சு. ஐயோ கிடைக்குமே காய்ஸ். நான் இப்போ பாருங்க, இங்க வந்து பாத்தீங்கன்னா யூ கேன் see that first of all find out the number n. n கண்டுபிடிங்க. n வந்து இதை பேஸ் பண்ணி இந்த கார்பனில் n இல்லை, because there is 3 hydrogen which is same group. இதை பேஸ் பண்ணி பாருங்க, இது ஒரு குரூப், இது ஒரு குரூப், இது ஒரு குரூப், இது ஒரு குரூப். So they have a chiral center. Am I correct my dear students? Right தானா? They have a chiral center. Now here இந்த கார்பனை வந்து பாத்தீங்கன்னா this is a group, this is a group, this is whole is a group, and this hydrogen is another group. So this is also having the particular chiral center. So n is equal to, as simple as that, it is 2. n is equal to 2. Now tell me whether it is a symmetrical carbon or unsymmetrical carbon. It's very easy. It's an unsymmetrical one. If it is symmetrical, here has to be same, here also has to be, there should be some similarities, right? So this is a unsymmetrical carbon. In the unsymmetrical carbon, if a equal to 2 raised to n, 2 raised to 2 which is equal to 4, 2 raised to 2 which is equal to 4. Now tell me m won't be there for this unsymmetrical one. Actually m is not won't be there for the, even though it's a double two chiral center one, m won't be there for the unsymmetrical one. So m is equal to 0. Now total isomerism சொல்றது என்னதா இருக்கும், a plus m which is equal to 4 plus 0 which is equal to 4. 4 plus 0 which is equal to 4. Now when you ask me about the racemic mixture, possible racemic mixture, அவங்க வந்து என்னெல்லாம் கேட்க மாட்டாங்க. They will just ask you how many possible racemic mixture is possible, how many racemic mixture is possible, அவ்வளோதான் கேட்பாங்க. So 4 by 2 which is a by 2, it should be 4 by 2 which is 2. 2 racemic mixture is possible from this. Clear everyone? Clear? Okay, now this one here, இங்க வந்து actually வேற எதுவும் நினைக்கிறேன், நிமிஷம். Okay, this is the one. Now listen carefully. What is the n? n is equal to 1. These two are the n, right? These two are the n because they do have this one, this one, this one, which is same, different. Here also different, right? So which is n is equal to 2. Here also we can say that this is a symmetrical compound. This is a symmetrical compounds because this is same, this is same, this is same, everything is same. So they have in the same position also. This is a symmetrical compound. Now symmetrical compound also, a is equal to a 2 raised to n. Am I correct? Optically inactive ஆன isomerism சொல்றது 2 raised to n which is 2 raised to 2 which is equal to 4. Now இங்க m இருக்குமா, m will be here. See m இங்க இருக்கும், இது பாருங்க, here there will be m. Okay, m will be like, if it is n is even and n is odd, n வந்து even இருக்கும்போது, do you know what is the value of the m? Please do tell me in the chat box. If m is even, this is your tartaric acid actually. So tell me, this is also symmetrical. m is, it is 2 raised to 2 by 2 minus 1, 2 raised to 1 minus 1, 2 raised to 0 which is equal to 1. Am I correct? Now total possible optical isomerism is a plus m which is equal to 4 plus 1 which is equal to 5. And racemic mixture which is equal to a by 2 which is 4 by 2 which is 2. 2 will be the racemic mixture here. Clear everyone? Those who are watching, clear? Okay, now coming to this point, this is actually asked in the NEET children. This is very important question also. They can expect it. We can expect it, this type of questions. So this is actually CH double bond CH. So you have to check the symmetry, right? I mean, in the CH double bond CH பக்கத்துல தான் இந்த symmetry நீங்க பார்க்கணும். This is an unsymmetrical compound, right? This is in unsymmetrical compounds. Unsymmetrical compounds are இருக்கும்போது நமக்கு என்ன தெரியும்? See, what will be the number of chiral centers? What will be the number of chiral centers here? See children, this double bond, how many chiral centers will be there? I mean, chiral center means, no, stereo centers. Stereo centers, that is much better word. Now, இதில் இன்னொரு விஷயம் கூட நான் சொல்கிறதுக்கு இருக்குது. I have missed a point also. There is another point I have to tell here. இப்போ உங்களுக்கு இந்த மாதிரி ஒரு question தந்துட்டு maybe they're asking you to find out the entire, what to say, one second. ஐயோ, ஒரே நிமிஷம் பசங்களா. Okay, in sometimes what happens means they will ask you to find out the total number of stereoisomerism. Stereoisomerism total is, you can understand that total number of stereoisomerism is which includes the geometrical isomerism as well as the optical isomerism. So we have to do the equation number of geometrical isomerism into number of optical isomerism. Total number of stereoisomerism அவங்க கேட்டாங்கன்னா we can conclude it like this: number of geometrical isomerism into number of optical isomerism. Clear? So this is a question where they ask you about the total number of isomerism, total number of stereoisomerism or stereoisomers. So in the மாதிரி question கிடைச்சிடுச்சுனா, you have to find out, firstly you have to find out the n value. What will be the number of n value here? What will be the n value here, children? You can see that this, between these two carbon there is a, see, between these two carbon there is two different groups is there. Between these two carbon also different groups are there. So this will be having a stereogenic one. Now this carbon, no, there will be CH3 here, CH or H, CH3. This is different group. Here also different group. Here also different group. Now, correct? So it will be n is equal to, you can say that n is equal to 1. So it will be like Gi will be like 2 raised to n, which is equal to 2. N is equal to 1, children. Equal to 2. Optical isomerism also 2 raised to n, which is equal to 2 raised to 1, which is equal to 2. So total number of isomerism total is equal to 2 into 2, which is equal to 4. Clear? N is equal to 4. There are total stereoisomerism. We can say that 2 in 4 stereoisomerism is possible. 4 geometrical isomerism and 4 optical isomerism. Total 4 stereoisomerism is possible. Clear, everyone? Clear? Just a second, children. Now next, one more question was there. Clear everyone? Okay. Now, next one is, okay, these are the things which we have already discussed. Okay. Now, there is another question, children, which is here. So, find the number of monochloro product, which is obtained from the chlorination of the following. So, there is N-butane. This is your N-butane. Isobutane. This is your isobutane. N-pentane. This is your N-pentane. Now, listen, you have to find out the monochloro product. Okay, you know that this is primary, this is secondary, primary carbons. So, whenever we are giving the Cl2 in the presence of the sunlight, you know that either they will be attaching to this particular primary chlorine, or they will be attaching to secondary chlorine. So when they are attaching to primary chlorine, means it's fine. But when they attach to secondary chlorine, what happens here is, you can see that there is a formation of the chiral carbon, right? This is the same, different. These are all, this is a group, this is a group, this is a group, hydrogen is another group, right? So this is another group, right? So there is a formation of a chiral carbon, four different valencies. Four valencies of the carbon is filled by four different elements. Now, whenever there is a chiral carbon, there will be having a plane of symmetry. They won't be having plane of symmetry, center of symmetry and all. You will be having dextro and levo, correct? Which means you will be having, again, they will be having three products of this. So total there will be three products will be there. Clear everyone? Clear? Now this, if it is isobutane, methane proper butane. So when this is the case, means primary will be the primary is the tertiary. So primary means you don't have any other possibility of forming the isomerism and optical isomerism. In the tertiary also you don't have any formality, because here all have the same CH3. So there is no formation of the chiral carbon. Whenever there is a chiral carbon only, there will be a possibility of dextro and levo, right? Now, while looking to this particular N-pentane, this is your primary, this is your secondary, primary. Okay, so this is your primary, secondary, primary. Now, see, whenever there is Cl2 is added in the presence of the sunlight, this can be added to your primary position or here also. So there is no carbon, there is no chiral carbon in this particular position. Now, when it is in the secondary position, children, just a second. Okay, that is something. Okay. So whenever there is in the secondary position, what happens? You can add it to here, correct? When we are adding it to the here, how you know that you have learned on the GOC, hydrogen will be displaced and one chlorine will be adding. That is, one chlorine will be adding in the form of the Cl plus, and it will be forming here, right? Hydrogen will be, they will be forming in the form of the HCl, right? So what happens means, this here we can add, and here when we are checking, this is a chiral carbon, because one is CH2, this is whole CH2, CH3, this is CH3, this is Cl, and here there is an hydrogen. So four valencies are filled by different carbon. So dextro and levo is possible. Whenever second one, this one is adding. Okay, when we add it to this one, there is no possibility of the chiral carbon. You have to check this also. This is also important. Okay, so what happens? There is no why there is no possibility? Because here also, same groups are attached, so chiral carbon is not forming. This is also possible. This here 2 is possible. So together it is not 3, it is 4. Clear? It is 4. Now in the neopentane, this is also in the neopentane also. Isopentane also. The isopentane also, it will be having the same formula. When you are adding to the tertiary position, you can say that there is a chiral carbon, so you will be having dextro and levo. When you are adding to the secondary position also, dextro and levo. So together we have to add it and we have to get it into the 6th product. Clear? I hope this is clear. And here there is no formation of the particular isopentane. There is no formation of anything here. Any dextro and levo and all. Okay, children? Clear, everyone? So now we are going to look into the conformational isomerism. We are going to study about the conformational isomerism. Before more look into the conformational isomerism, let's have a small break, children. We can come back by 5 o'clock, okay? Just be back by 5 o'clock. Hello children. Actually, I became a little late. I know that. Became a little late. So we have done with the isomerism and the confirmation portion நம்ம படிச்சிட்டோம். இனி நம்ம பார்க்க போறது கன்ஃபர்மேஷனல் நம்ம படிச்சிட்டோம். கன்ஃபர்மேஷனல் ஐசோமரிசம். What it is written? Conformational isomerism. Just a second. So before moving to that, isomers which are formed due to the rotation of the sigma bond. Sigma bond சொல்றது single bond ஓட rotation லான. There is a formation of the rotation. See, இப்போ இது வரைக்கும் நாம என்ன படிச்சிட்டோம்? There is a restricted rotation. Restricted rotation தான் நம்ம ஸ்டீரியோ ஐசோமரம், ஆப்டிக்கல் ஐசோமரத்துல எல்லாம் நம்ம படிச்சிட்டோம். ஆமாதானே? ஆனா conformational isomerismத்துல they are telling about the stereoisomers, which are formed due to the rotation of the sigma bond. Pi bond இருந்தா நமக்கு ரொட்டேட் பண்ண முடியாது. ஏன் pi bond இருந்தா ரொட்டேட் பண்ண முடியாது? Pi bond இருந்தா நமக்கு ரொட்டேட் பண்ண முடியாது. அதே வந்து single bond இருந்தா what happens? We can rotate it. For example, you have a compound this. Do you know what is the name of this compound? And this is what can you, is it visible for you children? சொல்லுங்க guys, visible? It's visible, right? Yes. So this is a carbon, this is a carbon. These are 3 hydrogen. Okay. This is another 3 hydrogen. இது வந்து எனக்கு எல்லாமே ஹைட்ரஜன் தான் கார்பனோட வேலன்சி. நான் எனக்கு தெரியாததுக்காக உங்களுக்கு தெரியாததுக்காக டிஃப்ரெண்டா கலர்ல கொடுத்துருக்கோம். So this is your single bond. My dear students, let me tell you one thing. In the single bonds, in the carbon single bondsல, if there is a restricted due to the rotation of the sigma bond வருந்தனால, see, there is a possibility of rotating of the sigma bond. Why there is a possibility? Because there is sigma bond only. இதே வந்து பை பாண்ட் ஆயிருந்தேன்னு வச்சுக்கோங்களேன். இப்படி பை பாண்ட் ஆயிருந்தேன்னா இந்த ரொட்டேஷன் பண்ணும்போது இந்த பாண்டே பிரேக் ஆயிடும். ஸோ தெர் இஸ் a possibility of the rotation of the sigma bond, and that particular isomerism, that particular phenomena is called as the conformational isomerism, or you can say that rotational isomerism. For example, I'll tell you what. See, this is a carbon which is having 3 ethene group. This is another carbon which is having 3 ethene group. When it is seeing like this, நீங்க முன்னாடி இருந்து பாக்குறீங்கன்னா இந்த பின்னாடி இருக்கிற கார்பன் உங்களுக்கு தெரியாது. அதே மாதிரி இந்த ஹைட்ரஜனோட பின்னாடி இருக்கிற இந்த ஹைட்ரஜன் உங்களுக்கு தெரியாது. பட் திஸ் இஸ் ஆக்சுவலி இப்படி பாக்குறேன்னு உங்களுக்கு தெரியுது இல்ல, அதே தான் நான் இப்படி காமிக்கிறேன். ஓகே, so this is actually the like, I hope it is visible, right? ஒரு நிமிஷம். Yes, this is visible, right? So this is your carbon, this is your 3 hydrogen, and this hydrogen have another back hydrogen and another carbon also, which is not visible for you. That is actually the rare carbon. Okay, that is not visible for you, and this carbon is visible for you. This hydrogen is also visible for you. So what happens here is you can rotate this carbon. In the carbon frontல இருக்கிற வச்சிட்டு இந்த frontல இருக்கிற carbon stable வச்சிட்டு we can rotate this carbon, right? So we can rotate this backside carbon as many times as we need. So there is a rotational carbon isomerism is forming. Because of this rotation, there forms the conformation, or that particular rotation leads to name of the conformational isomerism. So there can be infinite conformation of the compounds. There may be infinite, there can be infinite means infinite conformers of the compound. If you're taking the ethane, there can be infinite conforms of the compounds. Are you getting my point, children? Clear? So energy, see, one more thing, the energy which is required for this rotation of the sigma bond now, that is available at the room temperature. Room temperature la irukra energy la vechi da nama pannuvom. Adhe madri, like it can be like we can convert this particular one interconvertible. They are interconverted from one form to form. So it is literally difficult, and more or less we can say that they cannot separate it. They are not possible to separate it. So this is the one I'm going to show you. Before entering to this particular one, let me tell you for the condition of the conformational isomerism, you have to get the compound must be at least 3 sigma bond continuously. For example, you have the carbon, you have this particular tetrahedral carbon, okay, tetrahedral carbon. Now what happens means this is sigma, and another sigma is here, or this is sigma, this is sigma, another sigma is here. You have to get a sigma here. Then if that is, this continuous sigma is there. If that is a case, means there is a formation of the conformational isomerism. So in the case of this particular CH4, there is no conformational isomerism. In the case of this ethane, ETHEANE, ethane, ETHEANE. In the case of the ethane, there is 3 sigma continuously. So we can form the conformational isomerism. And in the case of the CI, CI. See, in the case of the conformational isomerism, in this particular one, sigma, 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 sigma. So, which means there is a continuation of the sigma. They can form the conformational isomerism. And in the case of the OH, see here also sigma and sigma. So, there is only 2 sigma is possible for this. This is OH2, O hydrogen, hydrogen. Okay. Oxygen 2 valencies are hydrogens. So there is no formation of the sigma particular conformational isomerism here. Here there is a formation sigma, sigma, sigma. Continuous sigma is there, na? 3 sigmas. They can be formed here also sigma, sigma, sigma. They can form it here sigma, sigma, sigma. But what happens, ma'am? Here also we can form, na? No, there is a pi bond is there. See, whenever there is a double bond, if you are rotating this particular double bond, what happens? There is a breaking of the bond breaking. If you have a double bond like this and we are rotating, it means okay. So the conformational isomerism is not possible here also, even in the case of this double bond also. Clear, everyone? Clear? Now, representation of a molecule. Listen carefully, children. I'll tell you. Listen carefully. So, let me tell you one thing. This is your tetrahedral carbon. You will be having another carbon here also, another valency here also. So I'm attaching a carbon here. So this is, do you know what is this molecule called, children? Do you know what is this molecule called? This molecule. Then a molecule theriyuma ungalku? Theriyuma, guys? என்ன molecules தெரியுமா? இந்த molecule என்னன்னு தெரியுமா? This molecule, this is an ethane molecule. You have carbon and 3 hydrogen here. All the hydrogens are same. For understanding purpose only, I have given different colors, okay? So this is 2 carbons and 3 hydrogens are there. This is the ethane molecule, okay? I hope this is clear. Now, let me tell you one thing. This is the front view. You have the carbon, you have the 3 hydrogen. And if you are looking to the another carbon, which is the back side of the, in the carbon, is the side view. In the front view, this is the front carbon and this is the rear carbon. You have the another carbon. You cannot see this carbon, right? And this hydrogen is also not visible. This hydrogen is also not visible. This hydrogen is also not visible. Only in the 3 hydrogen mattum da ungalku theriyudhu. Pinnadi irukra carbon adukku attach pannirukra hydrogen ungalku theriya mattingdu. Correct dana? Right? So this is the formula where, see, and in the particular front carbon irukula, in the front carbon da na vandu dot carbon, which means I'm representing it like this. இப்படி அந்த டாட் கார்பனா நான் ரெப்ரசென்ட் பண்ணது இந்த 3 ஹைட்ரஜன் and this one. Now பின்னாடி இருக்கிற கார்பனை தான் I'm just representing with the circle. Okay, பின்னாடி இருக்கிற கார்பனை தான் I'm just representing it with the circle. Circle வச்சு இந்த circle, இந்த கார்பனை தான் நான் circle வச்சு represent பண்றோம். And they do have what hydrogens in that. So அதே பொசிஷன்ல I'm also drawing the hydrogen. So I'm going to represent in a such a way that, listen carefully, I'm going to represent in a such a way that, see, இப்போ இதுல எந்த பிரச்சனையும் இல்லை. இதுல வந்து பின்னாடி இருக்கிற கார்பனை உங்களுக்கு காண முடியும். பின்னாடி இருக்கிற கார்பன் இல்லைனாலும் காண முடியாது. ரொட்டேஷன் பண்ணாலும் ஹைட்ரஜன் உங்களுக்கு காண முடியாது. நவ் ஐ எம் ஜஸ்ட் ரொட்டேட்டிங் திஸ் பர்டிகுலர் ஒன். லிசன் கேர்ஃபுல்லி ஹியர். இதை நான் வந்து ரொட்டேட் பண்ணிட்டோம். இப்படி இருந்தது. திஸ் வாஸ் லைக் திஸ். ஐ ஜஸ்ட் ரொட்டேட் இட் லைக் திஸ். ஓகே, இப்படி ரொட்டேட் பண்ணிட்டோம். இப்போ என்ன ஆச்சு பசங்களா? உங்களுக்கே தெரியும், இது வந்து இப்படி ஒன்று இருக்கு, அதுக்கு பின்னாடி Y ஷேப்ல வருது. Correct? Y shape வருது, which means I can draw it like this. பின்னாடி இருக்கிற 2 hydrogen, 3 hydrogen. See, I hope this is clear for you. This is seen for you. See, you have the hydrogen here. You have the 3 hydrogen here. பின்னாடி இருக்கிற 2 hydrogen, இங்க ஒரு hydrogen. புரியுதா? புரிஞ்சிருச்சா? This is the correct form. Clear? So you in between this you have the 2 hydrogen, and below also you have the 1 hydrogen here. Okay, this is what we are representing this through this. இதை வச்சு நம்ம represent பண்ணது இதுதான், this one. Clear everyone? Clear? So நான் வந்து first of all listen carefully. நான் வந்து இப்படி பார்க்குறேன். இந்த ஹைட்ரஜன்ல இருந்து பார்க்கும்போது இங்க ஒரு கார்பன் இருக்கு, இந்த ஒரு கார்பன் இருக்கு. ஓகே, இங்க ஒரு ஹைட்ரஜன் இருக்கு, 3 ஹைட்ரஜன் இருக்கு, இங்க பின்னாடி 3 ஹைட்ரஜன் இருக்கு. புரியுதா? So this is your front carbon and this one is your rear carbon. Now next one is the Sohaus projection. Sohaus projection எப்படி ப்ரொஜெக்ட் பண்றேன்னா, if I'm looking in this sidewaysல நீங்க ரெப்ரசென்ட் பண்ணும்போது this is the actual way. Here hydrogen, here hydrogen, here hydrogen, here hydrogen, here hydrogen, here hydrogen, which means this one. இப்படி பார்த்துக்கோங்க, இப்படி கரெக்டாக இருக்கும். See, this is a hydrogen, these two are hydrogen, these two hydrogen, that is these two hydrogen, these two hydrogen, these two hydrogen, these two hydrogen, and இங்க வந்து ஒரு bond, this is another hydrogen. You can see that. See, இது வந்து கொஞ்சம் இப்படி இருக்கும். Okay, this is another formula. Now அதே வந்து ஆப்போசிட்டாவும் இருக்கலாம். இப்போ இது வந்து இப்படி வருதுன்னு வச்சுக்கோங்களேன். இந்த ஒரு விஷயம் இருக்குல்ல, இந்த விஷயத்தோட சைட் வைஸ். So if it is 2 y is here, இது y-ஆ இருக்கு, y-யோட இன்வெர்டர் ஷேப் இருக்கு. See, y இங்க இருக்கு, y-யோட இன்வெர்டர் ஷேப் இங்க இருக்கு. புரியுதா? Okay, so this is how the representation, Newman's representation and the Sohaus representation. Sohaus representation means in the sideways representation, the Sohaus representation நம்ம சொல்றது. Okay, now bond angle சொல்றது. What do you mean by the bond angle? Bond angle means இப்போ ரெண்டு ஹைட்ரஜன் இங்க ஒரு ஆட்டத்துக்குள்ள இருக்கிற ரெண்டு ஹைட்ரஜனோட bond, I mean ஒரு ஆட்டத்துக்குள்ள இருக்கிற angle between the two atoms. ஒரு molecule, for example, listen carefully here. இந்த ரெண்டு angles இருக்குல்ல, these two angles, like these two angles, this is actually the bond angle. இதுதான் bond angle. ஒரு ஆட்டத்துல இருக்கிற ரெண்டு ஒரு I mean ஒரே ஆட்டத்துல இருக்கிற ரெண்டு bondsோட angle. For example, this is an atom and between these two bond, how many, what is the bond angle? Between these two, what is the bond angle? That is the bond angle. Now dihydral angle, இதுதான் எல்லாருக்குமே நிறைய பேருக்கு கன்ஃபியூஷன் ஆயிடும். இந்த dihydral angle சொல்றது, listen carefully. Dihydral angle is the angle between two bonds presented at adjacent atoms. ரெண்டு bond ஓடது. For example, so this is your 1 carbon or 3 hydrogen. Now listen carefully. This was your second carbon also, which was on the rear side. This was on the rear side, my dear students. Now I'm just rotating that particular one and it comes into this category like this. Okay, rotate பண்ணிட்டு என்ன ஆயிட்டாங்க, ஐயோ ரொட்டேட் பண்ணிட்டு என்ன ஆயிட்டாங்க, இது இப்படி வந்துருச்சு, இந்த ஒரு பொசிஷன்ல வந்துருச்சு. இங்க 3, இங்க கீழே வந்து இந்த சைட்ல 2. இப்போ இதுதான் ரொட்டேஷன்ல இருக்கு. இந்த ஆங்கிளும் இந்த ஆங்கிளும் இருக்கிறது, இது வந்து ரெண்டு அட்ஜசன்ட் ஆட்டம். இந்த கார்பனும் ரெண்டு அட்ஜசன்ட் ஆட்டம். இந்த பர்டிகுலர் ஆங்கிள் between these and this one, this is your dihydral angle. Are you getting my point, children? This is your I'm repeating it again. This is an atom, this is an atom, this is an adjacent atoms, and the bond created by this particular first atom and this atom, which is ரெண்டு, இதுதான் dihydral angle சொல்றது. Clear? This is your dihydral angle between these two. This is your bond angle. இது bond angle, இது dihydral angle. I hope that is clear. Clear everyone? Clear? That is actually your dihydral angle. Now steric strain and torsional strain. This is also another 2 important point. Do you know what is steric strain? Repulsion between 2 or more atoms. அது வந்து எப்படின்னா, ஒரு நிமிஷம், இப்போ இந்த ஆட்டம் இடையில ஒரு ரிப்பல்ஷன் இருக்கும். தட் இஸ் ஆக்சுவலி ஸ்டெரிக் ரிப்பல்ஷன். ஆட்டத்தோட ரிப்பல்ஷன் தான் ஸ்டெரிக் ரிப்பல்ஷன் சொல்லுது. நவ் டார்ஷனல் ஸ்ட்ரெயின் இஸ் கால்ட் அஸ் ரிப்பல்ஷன் பிட்வீன் தி எலக்ட்ரான் பெயின் ஆஃப் 2 bonds at the adjacent atom, which means இந்த ஆட்டத்துக்கும் இந்த ஆட்டத்துக்கு இருக்கிற இந்த பாண்ட் இருக்குல்ல, listen carefully. இந்த ஆட்டத்துக்கு, this particular first carbon and second carbon, there is a bond between red color and yellow color. இந்த பாண்டுக்கு 2 electrons இருக்கும். இந்த ஒரு பாண்ட்ல 2 electrons இருக்கும், இந்த பாண்ட்ல 2 electrons இருக்கும். This will also 2 electrons, this will also 2 electrons. அந்த electron repulsion தான் என்ன சொல்றது, torsional strain சொல்றது. adjacent ஆட்டத்துல இருக்கிற பாண்டோட repulsion தான், that is a torsional strain. Clear? Clear everyone? புரிஞ்சிருச்சா? கொஞ்சம் படிங்க. Just read it one time. Read it one time, children. Just a second. I'm sorry, children, one second. ஒரு நிமிஷம் பசங்களா. Just a second, children. Just read it whatever is given to you. Okay. So this is all about this particular bond angle and bond strength. Now we can go to the formation of okay, they have already given me formation of the configurational isomerism. எப்படி கன் பண்றாங்கன்னு பார்க்கலாமா? So one second, I will just take the just a second. இங்கே சேமா இருக்கிறதா இருக்கிறேன். ஒரு நிமிஷம். How it works, I don't know. I'll just check it. One minute, guys. No, not it. That's not the option. Just a second, children. Give me a second. I will just. Listen carefully to everyone. Those who are in the class, please do listen. This is an important topic, okay? So children, let me tell you one thing. So this is your particular ethane molecule, and I'm just giving in such a way that, see, these are your hydrogen. This green orange color is your hydrogen, this blue color is also hydrogen. Consider the top one, which is, this is your X and this is your Y. Okay, in the idhula kodutha madri, this is two hydrogen. First one hydrogen is the orange color, and this is the X, which is yellow in color. This is the Y, which this is hydrogen, which is blue in color, and this is the Y, which is red in color. Okay, clear everyone? So this is what they have given you. Okay, now first, you know that what will be happening. You know that this will be the first one. So we are going to draw this. One second. I will draw it. Okay, so you have your carbon, hydrogen, 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 and this is your X, this is your Y. Okay, so this is your X and this is your Y. So we know that the front carbon will be drawing in the form of, how children, the front carbon will be drawing the form of dotted one, right? Dotted one, and little more lengthier one. Okay, so they have the hydrogen here. So hydrogen, hydrogen, and in the top they have the X. Okay, in the top they have the X. This is the yellow in color. Now backside carbon, we will be drawing in the shape of the circle. Am I right, my dear students? We will be drawing in the shape of the circle. Now I'm just drawing that, and now you have this one, which is the backside of this. You have the particular Y. Y is the two hydrogen is there. So basically Y here and hydrogen, hydrogen. Am I correct, my dear students? Or else you can draw it like this also. Hydrogen, hydrogen. Okay, so this is the formula. So this one is the first normal one. Here you can see that what are the things you can, this particular formula or this particular shape is called as the eclipsed one. Okay, what is the shape of this? This is the eclipsed one. See, you can see that they are directly backside, correct? Which means this this particular X and Y on the backside, these two hydrogen are on the same this side, and these two hydrogen, right? This is the exact position. Okay, I hope this is clear. And you can see that this, between this X and Y, there is a steric hindrance. Am I correct? Steric hindrance will be there. Am I right? Steric hindrance is more, and also you can see that torsional strain is also more, right? Torsional strain between these two angles, between in the bond angle இப்படி இருக்கும்போது they have more torsional strain also. So torsional strain is also more here. Clear? Torsional strain is also more here. These are the 2 points which you got from this particular one. Okay. Now what happens means, listen carefully children. Now I'm just making that particular one to 90-degree rotation. எப்படி 90-degree rotation நடக்கும்? I mean not 90-degree. First of all, you can go for the 60-degree. I'm sorry, 60-degree rotation. ஐயோ இங்கடா போச்சு. 60-degree rotation. 60-degree rotation எப்படி நடக்கும் பசங்களா? Just think about it. See, this was the first side, this was the back side. Now, this is your 160-degree rotation, right? Which means இப்படி ஆயிடுச்சு. புரியுதாடா? இங்க இருந்தது இது பாரு, இங்க ஒரு இந்த மாதிரி ட்ரையாங்கிள் வந்துருச்சு, இங்க y வந்துருச்சு. See, which means இப்படி ஆயிடுச்சு. You can see this, right? Which means உங்களோட x இங்க இருந்தது, y இப்போ என்னாச்சு, between these two ஆயிடுச்சு. So which means I can write it like this. This is your x, this was your x, this was your hydrogen children, this was your hydrogen. Now you have the carbon here. What happened to the y children? What happened to the y? Ma'am, y x in the hydrogen பக்கத்துல வந்துருச்சு ma'am, right? Which means in between this y, here hydrogen, here hydrogen. Am I correct my dear students? Right? That is what happens here, right? See, உங்களுக்கு இது பார்த்தா தெரியும் நினைக்கிறேன், if I'm not wrong. Between these two one, listen carefully, between this angle and this angle now, that is actually a 90-degree. The dihedral angle is 90-degree. Clear? Clear everyone? Clear? Okay. So now what happens means, again this is undergoing in another 60-degree rotation. Okay. And one more thing. Here this is your Gaussian. Okay. This is undergoing in another 60-degree rotation. What happens to the 60-degree rotation? If it was this type, this much. இப்படி தான் இருந்தது. 3 இப்படி இருந்தது. இது உங்களோட எக்ஸ், இது உங்களோட y. மறுபடியும் ஒரு 60-degree ரொட்டேஷன் சொல்லும்போது எப்படி ஆயிருக்கும், இப்படி ஆயிருக்கும். இப்படி இருந்தது. See, it was like this, and now again a 60 rotation means this will be going to this side, which means இந்த எக்ஸுக்கு பின்னாடி ஹைட்ரஜன் வந்துருச்சு, இந்த ஹைட்ரஜனுக்கு பின்னாடி தான் உங்களோட y வந்துருச்சு. கரெக்ட்? which means you can write it like this. கான்செப்ட் புரிஞ்சு போங்கடா, சும்மா படிச்சு வச்சுட்டு யூஸ் இல்லை. If you know the concept only, it is good, or else there is no use, my dear students. So you have the x here, hydrogen here, and the other angled rear side carbon எங்க வந்துருச்சு பசங்களா சொல்லுங்க? எங்க வந்துருச்சு? இந்த ஹைட்ரஜனுக்கு பின்னாடி இந்த ஹைட்ரஜன் வந்துருச்சு. கரெக்ட்? இதுக்கு இங்க இந்த எக்ஸுக்கு பின்னாடி இந்த ஹைட்ரஜன் வந்துருச்சு. which means hydrogen will be here, y will be here, and one second, hydrogen இங்க வந்திருக்கும். Hydrogen will be here, and your y will be here, and here you have an either hydrogen. Correct? In the x, in the hydrogen. இங்க hydrogen இருந்தது friend, இங்க தான் உங்களோட y இருக்கு. Clear everyone? Clear? So this is your partially eclipsed one. Partially eclipsed one. Clear everyone? Clear? Now again, one second, I will size கொஞ்சம் கம்மி பண்றேன். Again you have the 60-degree. Okay, again you have the 60-degree rotation, which means இங்க இருந்தவங்க என்ன வந்துருவாங்க, இப்படி வந்துருவாங்க. x இங்க இருக்கு, y கீழே வந்துருச்சு, இப்படி rotation ஆயிடும். This is the angle. X was here and y was here. This will be the rotation. This will be your rotation. I hope this is clear. X is here, y is here, down. This is going to be your rotation. So here will be your y. Am I correct? Here will be your y. Here will be your x. H. Here will be your h. So this name is your anti or staggered one. Anti, or we can call it as staggered one. Okay. Again, it will be undergoing a 90 degree, 60 degree of rotation. So என்ன ஆயிடும் மறுபடியும் இது கீழே வந்துடும் ஆமாதானே so it will be like this is your H. Clear? So this is your going to be a partially eclipsed one. Now again இது ஒரு 90 degree rotation போகும்போது எப்படி வந்துடும் between this side, right? It will be like this is the third, fifth, sixth, last position now. So this will be here, it will be y. Here it will be h. So this is going to be your eclipse, Gaussian, partially eclipsed, anti-staggered, partially eclipsed, and you have Gaussian. Clear everyone? Clear? So the potential energy, you can see that, see whenever the potential energy more, stability less. So angle strain அதிகமாகும்போது potential energy அதிகமாயிடும், stability கம்மியாயிடும், which means which will be having the potential energy order, which will be having more potential energy, which will be, you will be having, eclipse will be having more potential energy, correct? Eclipsed, then partial eclipse, eclipsed, then you will be having your Gaussian, correct? This one and this one, Gaussian, then staggered will be having least potential energy and more stability. So stability order will be like, first one it will be staggered, okay, I will write it in the order. Eclipse will be having least one, then partial eclipse, then Gaussian, then staggered. Staggered will be having less potential energy, more stability. See, it's because this one hydrogen in the x or bulky group, x y bulky group, they are in the opposite side. So that's why the angle strain is less, they have less steric hindrance, and they will be having less strain, so they will be having more stability. Clear everyone? Okay, they are different group and they can be a bulky group also, na? Clear? Now while we are checking the particular diagram, one second children. Okay, so now we are going to like check into the diagram. Okay, normal diagram. So diagram, one second, I will just take the NCERT for that. Okay, now we are going to look into the diagram. So diagram, while we are writing here, give this as eclipsed one. Okay, this is your partial eclipse, partial eclipsed. Then you have your Gaussian. Then you have your staggered one, which is having, okay, I didn't write here, less potential energy, and this is the angle, dihedral angle. Okay, so when dihedral angle is almost, I'm telling you, 60, 120, 180, 240, 300, 360. Okay, so least potential energy will be staggered, that will be having more stability. Okay, now while we are drawing it, listen carefully. So eclipse is having more potential energy, so they will be having a starting position. Then you know which one will be coming, which one will be having. See, first eclipse will be coming, then here the Gaussian will be there. Okay, next again, see, Gaussian is the second one now, which is given in the particular list. See here, check this one first this one first will be this one. Okay, this will be the eclipse. Then you have the Gaussian, correct? Then you have the Gaussian. Then you got this particular partial eclipse. Then you have the anti-staggered, right? So this is one, okay? Anti or staggered one, right? So you have the Gaussian, which is having less when compared to the partial eclipse. Then again you will be having your partial eclipse, correct? Partial eclipse will be having more potential energy. Then after partial eclipse, what is there? And stagger will be coming, right? They have the least one, right? Then again partial stagger, then you again have your partial eclipse, right? So this is again you come, then again you have your Gaussian, then again you have your eclipse. So this one will be shoe. Okay, you have your partial eclipse. Okay, from the partial eclipse you got the staggered one, from the staggered you got your Gaussian again, and you have your eclipse again. Okay, so this is going to be your one. So we can say that this is the first one, eclipse. So I will color it in different way. First one, second one, third one, fourth one, fifth one, sixth one, seventh one. Clear, everyone? Clear? Clear? Okay, so this is the order. This is the we can say that the diagram. Graph between the potential energy and dihedral angle. Clear, everyone? Clear? Okay. So this is all they are telling about. Those things are not required. Now, conformation of ethane. Now we are going to look into the conformation of ethane. Conformation of the ethane molecules. So ethane, you know that, see, I told you about carbon is there and hydrogen is here and hydrogen is here and hydrogen is there, another carbon, hydrogen, hydrogen, hydrogen. So instead of this hydrogen, I was giving you X and Y. Instead of that X and Y, I'm just writing you here. This was your X, this was your Y, hydrogen, 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 hydrogen. Instead of that, I'm just writing your, listen carefully, here I'm just giving you the, okay, instead of the CH, I'm giving you the ethane. Now ethane we have already discussed, if I'm not wrong, that same thing only now. So hydrogen only. Okay, I thought of taking with the butane first. Okay, hydrogen is better, hydrogen only. Okay, clear? Now listen carefully. So we know that X and Y is belongs to the hydrogen. So what will be the formula? First one, this is going to be your front carbon, hydrogen, hydrogen, hydrogen. And tell me which one will be your rear carbon. This is going to be your rear carbon, and you have in the first position hydrogen will be here, hydrogen will be here, hydrogen will be here. Am I correct? Now it is undergoing a 60 degree of rotation, and this particular one is called as what? This particular one is called as eclipse. Am I correct? This is called as the eclipsed one. Now this is undergoing the rotation. Now you again have this front carbon. Front carbon will be stable. The back carbon will be undergoing the rotation. This is also a very important point, children. So this is undergoing the rotation, and you have the hydrogen here. You have the hydrogen here. You have another hydrogen here, which means that will be having and the hydrogen here, right? Correct? So that will be having what? It is your staggered one, right? It is your staggered one. Gaussian, or we can say that that name is actually in the particular ethane. We will call it as staggered. Okay? Staggered one. Now again, the staggered one is undergoing the 60 degree rotation. So this will be coming here. Correct? ஏற்கனவே நம்ம பார்த்தோம். அதனால தான் நான் வந்து இது குரூப் இதில் மறுபடியும் அந்த ஒரு இது எடுத்து காமிக்கல உங்களுக்கு. Now what happens? இப்போ என்ன ஆகிடும்? இந்த ஹைட்ரஜன் பக்கத்தில் வந்துடும், right? இந்த hydrogen will be coming backside of this. All the hydrogen will be backside of the front carbon, right? Again, this position, this is again called as the which one? This is again called as the eclipse only. Okay? This is again called as the eclipsed one. Now again 60 degree rotation is undergoing. You have the hydrogen. Front hydrogen is not having any change. Only the back hydrogen is undergoing the change, right? Now what happens to this? You will be having a hydrogen here, hydrogen here, hydrogen here. This is your staggered form, right? Third one, I mean fourth one. Staggered form, right? Correct? Now again this will be undergoing a 60 degree of rotation. Rotate பண்ணும்போது என்ன ஆயிடும் பசங்களா? Hydrogen, 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 and you have this. Again இது rotation போகும்போது it will be coming to this position. Hydrogen 60 degree தானே. It can go to infinite rotation, okay? There is no such category that they have to go this much rotation only. அப்படி எதுவுமே இல்லை. So this is again undergoing, this is also your eclipsed one, okay? This is also again undergoing the 60 degree rotation. Total there is 6 1, which means 360 rotation it is undergoing. Which is your staggered one. Clear, everyone? Clear? So when we are telling about this one, I will just write it. I will just make it simple. Okay. Now while we are drawing the particular one, நம்ம வந்து அதோட இது வரைக்கும் போது அந்த கிராஃப் வரைக்கும் போது எப்படி வரைப்பாங்க பசங்களா? You have y axis and you have your x axis. In the y axis you have your potential energy. Here you have your dihedral angle, which is like 60, 120, 180, 240, 300, 360. Okay. Now Listen carefully. Potential energy will be maximum for the eclipsed ones, right? Because they will be having minimum energy, right? So what happens here is, you can see that when it in the first position, okay, the potential energy is for the eclipsed one. Okay, this is, I will write it, eclipse, and this is your staggered one. So potential energy will be maximum at the position of the 60 degree. 60 degree it is comes, and then it is went to here, the potential energy is minimum staggered. Then again it comes to here, then it comes to here, then comes to here, secondary, then it comes to here, here, and here. And wait. It comes to here. Along the 60 degree, it will be eclipse, it will be more potential energy, which is on the 120 degree now. One second, children. Just a second. So this is a kind of like potential energy 60 degree. Okay, it will be coming to the 120 degree. It will be minimum for during the staggered position. Then when it comes to the 80 degree, 180 degree, 120, not 180 degree. One second. First in the 60 degree. This is wrong. Here, during the 60 degree staggered will comes. 180, 120 degree again it comes. Okay, during the 180 degree again it comes down. Okay, during the 240 degree again 246, 620, 81 for 240 degree again it goes to this eclipse. During the 340 degree, 300 degree again it's come to the staggered. Then in the 360 degree it will be going back. Okay, so this is going to be a first one, second one, third, fourth. One second. First one is from there. First one, second one, third one, fourth one, fifth one, sixth one. Again first one, staggered will be, eclipse will be again starting it. Clear? So when we are checking about the potential energy will be more for the eclipse one, correct? So which one will be having 1 is equal to 3 equal to 5. They are all eclipse one, right? Eclipsed one is more than 2, 4, 6. They are all comes under the category of the staggered one. Stability order will be staggered is greater than the eclipsed. Clear, everyone? Clear? Those who are watching it, clear? புரியுதா பசங்களா? இங்கே நான் கரெக்டாக தானே கொடுத்துட்டோம். $60, yes, correct. புரிஞ்சிருச்சா பசங்களா? You got it? How it's the ethane? Now, உங்கள் டெக்ஸ்ட் புக்கில் இருக்கிற ஒன்று இருக்குது, that is very important, confirmation of the butane, which is very, very important, children. Confirmation of the butane. I have to take this also. One second. Confirmation of the butane. I will write it with another color. This is there in your textbook also, okay? Confirmations. Conformers of butane. So conformers of butane, how will you write it, my dear students? Tell me. How will you write the butane? You have the CH3 hydrogen hydrogen. You have a hydrogen here, correct? You have a CH3 here, hydrogen and hydrogen, correct? Which means you can say that inga vandu pathina, this is going to be a CH3, this is going to be another CH3. 2 hydrogens is here, 2 hydrogens is here. I mean like this. Sorry. This is your CH3, this is your CH3. Hydrogen, 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 hydrogen. Okay, clear? So this is how it works. Okay, so instead of that X, we are going to be CH3. Y is also going to be CH3. Clear? Clear, Pakka? Did I want to increase the size a little more? Okay. Now, listen carefully. So the front side carbon, okay, okay, one second. Front side carbon, you have the first sign CH3, hydrogen, hydrogen. Now, on the back side carbon, rear side carbon, you have rear side carbon line. Again, you have the CH3 here, you have the hydrogen here, and you have the hydrogen here. See, listen, CH3 inga, hydrogen inga, hydrogen inga. This is your front carbon. Back carbon is CH3 inga, hydrogen inga, hydrogen. Pinnadiye irukku. Adha represent idu rendu da CH3. Okay, idha represent pannadhukku ipdi eludirukom. Okay, so this is your eclipsed one. Now you are going for the 60-degree rotation. When it is going for the 60-degree rotation, front side carbon, there won't be any change for them. CH3, hydrogen, hydrogen. Backside carbon, they are undergoing the rotation, right? Backside carbon is undergoing the rotation. Now there will be changing into the CH3, hydrogen, hydrogen. So this you may expect a different, same name here. Idoda peru and Gaussian. This is your second structure. This is your second structure. This is your first structure. Okay, again they are undergoing the 60-degree rotation. You have the CH3 here, hydrogen here, and hydrogen here. So this is going to be your partial eclipse. Partial eclipse, which is your third structure. Again they are undergoing the 60-degree rotation. Again they are undergoing the 60-degree rotation. The front side carbon and the hydrogen and the CH3 does not have any change. Back side na avanga vandu rotation povanga. So in the back side, what will be happening, my dear students? In the CH3 on the middle portion la vandru. Here CH3, here hydrogen, here hydrogen. So this is the most stable structure, children. This is the most stable structure. See, இப்படி இருக்கும். இப்படி இருக்கும். எப்படி இருக்கும்னா, this is your CH3. This is your CH3 and another carbon on CH3 இப்படி இருக்கும். இது வந்து இப்படி பூ மாதிரி இருக்கும். இது வந்து இப்படி Y மாதிரி இருக்கும். புரியுதா? So this will be the structure. இப்படி இருக்கும். This is the CH3, this is the CH3. கீழே வந்துடும். I hope you can see this. இப்படி இருக்கும். Clear? Okay, now this is the most stable, the stablest structure, children. That is your fourth structure. What is the name of it? Staggered one. Okay, staggered one. Now fifth one is, again they will be undergoing the rotation. CH3, hydrogen, hydrogen. You have the CH3 in the back side of this hydrogen, hydrogen. Do you know what is the name of this one? Fifth one, partial eclipse again. Again they will be undergoing the 60-degree rotation, CH3. இங்கே வந்து பார்த்தீங்கன்னா மேம் இதுவும் ஸ்டேபிளாக இல்லை கேட்கலாம். ஆனால் இங்கே வந்து அது 2 பல்கி குரூப் ஒரே சைடில் இருக்குது பசங்களா. புரியுதா? 2 பல்கி குரூப் வந்து ஒரே சைடில் இருக்குது, விச் மீன்ஸ் திஸ் இஸ் ஆல்சோ a stable structure only, but still when it is compared to the other structure staggered one, this is less stable. Here also 2 பல்கி குரூப் ஒரே சைடில் இருக்குது, அதனால தான் அதுக்கு ரெண்டுக்குமே ஒரே நீ. Clear everyone? Clear? So same thing will be happening for their particular graph also. And if there is one more point I have to add here, children, I will write this. If there is a presence of, if there is a presence of, or if there is a presence of force of attraction between X and Y. X, Y, which means like we can say that like hydrogen bonding. Okay, hydrogen bonding and all. Any electrostatic force of attraction, like any hydrogen bonding or electrostatic force of attraction and all, then Gaussian is the stable one than the staggered one. Staggered one தான் usually stable. ஆனால் இந்த கோஷே ஸ்டேட்டில் வரும்போது ஏதாவது ஒரு ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் இருக்கிறதுக்கு சான்ஸ் இருந்தேன்னா அப்போ யாராக இருக்கும்? கோஷே வில் பி மோர் ஸ்டேபிள் தேன் தி ஸ்டாகர்ட் ஒன். This has been asked in one of the exams. I don't remember which exams. I guess it was in the NEET exam. If I'm not wrong, question வந்து it was ethylene glycol. Ethylene glycol, which means, one second, what is the formula of ethylene glycol? CH2OH. Okay, which means I can say that like this can be like carbon, hydrogen is there, hydrogen is there, hydrogen is there, hydrogen is there. X and Y are OH and OH. So what happens? There is a formation. If I'm writing the particular Gaussian formula of this one, this is your front side carbon, OH, hydrogen, hydrogen, and this is going to be your backside carbon, which is like this. This is OH. இப்படி OH வந்துடும், இங்கே ஹைட்ரஜன் வந்துடும், இங்கே ஹைட்ரஜன் வந்துடும். So what happens here is there is a formation of the particular hydrogen bonding. See, I'll tell you one second. See, இப்போ இதை வந்து இப்படி எழுதிக்கலாம், அப்போ தான் இன்னும் பெட்டராக அண்டர்ஸ்டாண்ட் பண்ணுவீங்க. எந்த கலர் எடுத்துருக்கேன்? இப்படி ஹைட்ரஜன் பாண்ட் வரும்ல, OH OH. So what happens means this is delta positive and this is delta negative. So they will be having a hydrogen bonding. This is your Gaussian structure. So that is the reason why Gaussian will be more stable. Yes, Sarvesh, I'm taking that preparation of the alkenes also today itself. Hydrocarbonல இன்னைக்கு நான் வந்து இது முடிச்சிடுவேன். இப்போ this is almost done, children. Only 2-3 examples only. This is almost done. If it is done, I will start with hydrocarbons. Hydrocarbonsல வந்து alkenes இன்னைக்கு நான் முடிச்சிடுவேன். Preparation of alkenes. Preparations will be taking. Properties I don't know whether I will be able to take that, but preparations I will be taking. What happened, Sarvesh? Okay, this has been asked, and if I'm not wrong, they are asked also. அது எந்த எக்ஸாமுக்கு எனக்கு ஞாபகம் இல்லை, நீட்டில் நினைக்கிறேன், அது எய்ம்ஸில் கேட்டிருக்காங்கன்னு நினைக்கிறேன். 2-fluoroethanyl also, 2-fluoroethene, எத்தனால் தான் அவங்க கேட்டிருக்காங்க. விச் மீன்ஸ் அவங்களுக்கு வந்து CH2OH and fluorine. There also they have asked it, because OH will be having delta positive, this will be having delta negative, so there will be a structure between them. Okay, so they have asked that also. So due to this particular, due to the hydrogen bonding Gaussian structure is more stable than staggered one. Okay, clear? This has been asked. This is very important. This is actually going to give you the name of doctor. Very important, my dear students. Okay, any doubts, guys? Shall we move to the next one? Clear? Now confirmation இனி எனக்கு தெரிஞ்சு NCERTல இன்னொரு டாபிக் இருக்கு. ஸோ திஸ் இஸ் கன்ஃபர்மேஷன் ஆஃப் த சைக்ளோஆல்கேன்ஸோடது கேட்டிருக்காங்க. ஓகே, கன்ஃபர்மேஷன் அது ரொம்ப கட்டியாக இருக்கு. ஒரு நிமிஷம், நான் கொஞ்சம் ஸ்பீடாக எழுதும்போது என்னோட ஹேண்ட் ரைட்டிங் கொஞ்சம் கேவலமாக இருக்கும். Confirmation of, why I'm writing confirmation? Conformers of cycloalkanes. Cycloalkanes-ஓட conformers பற்றி படிக்க போகிறோம். So first of all, this three groups are there now, like and the cyclopropane, in the cyclopropanes, I mean cyclopropane, and you have cyclobutane, cyclopentane and all. They won't be till hexane. I'll write here. You can take it as a note. Cyclopropane. Okay, I'll write it. Cyclopropane, cyclobutane, pentane, hexane and all. They do not show conformational isomerism due to the angle strain. Angle strain இருக்கிறதுனால, between the ankles now they have more repulsion, more strain actually. So due to that, what happens, they won't be showing any conformational isomerism. Okay, angle strain இருக்கிறதுனால. So we are discussing about the conformation of the conformers of cyclohexanes, which is given in the textbook, which is given in your NCERT textbook. NCERT எடுத்துட்டேன்னா படிக்க முடியும். So they are just like அவங்களோட first formula சொல்றது, formula ways நான் சொல்றேன். They have the first name. Their first name is the chair form. Then you have the twist board. And the name of the shape மட்டும் தான் இருக்கு. Then you have the bot form. Then you have the half chair. Do you know how it looks like? Just a second. Chair one na. I'll draw the carbons. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Okay, now twist bot. This is little tricky one. ஒரு நிமிஷம் பசங்களா. ஐயா, ஒரு நிமிஷம் எனக்கு இது இங்கே வரும்போது கொஞ்சம் கஷ்டமாக இருக்கும். இது எப்போவுமே வரைக்கும்போது எனக்கு கஷ்டமாக இருக்கும். நான் like when I'm studying also, this was the one which is very difficult for me to draw. This is actually like இன்னும் கொஞ்சம் பெட்டராக இருக்கணும். இருங்கடா, ஒரு நிமிஷம். இங்கே ஒரு கார்பன் இருக்கு. So I will write the carbon. Where are the carbon? One carbon here, one carbon here. You will be having another carbon here, another carbon here. 1 2 3 4 5 6. Okay, now next one, bot form. Now bot form is easy. This is not the exact way, like it's a kind of 1, 2, 3, 4, 5, 6. This is your half shell. One, 2, 3, 4, 5, 6. This is your half shell. Okay. So always remember the stability order of this one. Stability order. Oh, I'm having this headache. Chair form is the most stable one. Okay, chair form is the most stable. Then you have your twist board. Then you have your board. Then you have your half chair. You don't want to know the, I mean, just understand the stability order. That is more than enough for you guys. Okay. Now next topic is Newman 2. One second. I'll add in next topic. Now, how to convert, this is another important point. Now, this is also another, we are about to done. We are done. 2 topics only. We are done with our isomerism. So, it's a name now. So, we have to write it in the capital letter. So, to which form? Which dash formula? Maybe if they ask you to find out something, what you guys will do? So you have to know how to convert the house to okay, so house to particular wedge dash. Adhe madri so house formula you have to understand how to write the Fisher projection, because they will ask you something in the something which is related to the optical isomerism by giving the formula of the saw house or your this one Newman or something. Okay, then Newman to Fisher. Newman to Fisher projection. Listen. So you have given first of all Sohaus formula. Listen carefully. Sohaus formula, you know how it is, right? So they will be like, this is your Sohaus formula. Okay, we draw it a little more bigger. A, B, X, Y. Consider this, okay? And you have a compound XZ. Yeah. Okay, clear? This is the consideration. So listen carefully. This carbon, this particular carbon, listen carefully. I'm going to write out the which formula of this, okay? This particular carbon has a bond like this one, and this one, right? I mean, this one, and this one, right? Which means these 2 bonds are on the plane, okay? And these 2 bonds are there, na? One is looking away from you, one is looking towards you. I mean, I told you, na, wedge will be looking towards you and the dash will be looking away from you, okay? Same thing here also. This carbon will be having this bond and this bond, which is on the plane, okay? On the plane. And these 2 bonds are look away from the plane, which one is away from the plane, which means one will be looking towards you and one will be looking away from the viewer. Clear? So when I'm drawing this particular one, அதை எப்படி வரைக்க முடியல எனக்கு அதை எப்படி மேம் வரைக்கிறது காமிக்கிற பாருங்க ஸோ லிசன் கேர்ஃபுல்லி ஸோ இதை வந்து நான் எனக்கு எப்படி வரைக்க முடியும் பசங்களா this A is there now. So when I'm checking this particular one, I can say that Z is there and you have your C also. என்னடா இன்னைக்கு வரைக்கிறது எல்லாமே எப்படி ஆகுது Z C. A is actually, just consider this A is actually the which one? I mean dash one. Now you have the which one on B. When A is the which one means C. Listen here. This is the formula. This is the thing, right? This is the thing and see, this is your A and B. This is your C. This is your X and Y. This is your Z. So what happens means while I'm looking like this, I can say Z is here. Now this is the A. If A is there, A is here. This A is considered as the dash. This also considered as the dash, right? So which means I can say that X also considered as the dash. And I mean, you have to color it, children. This is X. And this is considered as the Y. Clear, everyone? Clear? This is how you draw it. Clear? Now, if they give you this one particular one, just a second. இந்த மாதிரி கேட்டுக்கலாம். Okay, listen carefully. If they give you like this. இப்படி கொடுத்திருக்காங்க, which means this is your X, same thing. No, this is not your X. Z, Y, அப்படியே கொடுத்துக்கோங்க. This is your A, B and Z. See. So how will you going to do this? Same thing. இங்க வந்துரும். இங்க Z இருக்கிறதுல C இருக்கிறதுல C வந்துரும். X இருக்கிறதுல X வந்துரும். இங்க வந்து பாத்தீங்கன்னா see, one is like this and one is like this. இப்படிதான் கொடுத்திருக்காங்கடா. இது இப்படி இருக்கு, இது இப்படி இருக்கு. ஓகே, இப்படி கொடுத்திருக்காங்க. இது வந்து இப்படி இருக்கு. இது வந்து இது இந்த ஒரு ஃபார்ம் இருக்குல்ல. ஓகே, இது நான் கொடுக்குறேன். இப்படி இருக்கு. This is the form. This is 2R on the top. Y, this is on the lower. This is on the top. This 2R on the lower. So we can say that this is going to be your A and this is going to be a B. Now, at the same time, which one? இங்க வந்து இது செட்டா கன்சிடர் பண்ணிக்கோங்க. listen. இப்படி இருக்கும்போது this was your set, this was your X and Y. இப்போ இது இப்படி ஆயிடுச்சு. இது sorry இது. So you can say that this was your this. See, listen carefully. எனக்கு கன்ஃபியூஸ் ஆயிடுச்சு ஒரு நிமிஷம். Okay, this is your X and this is your Z and this is your Y. So if you are writing A and B here, இதில் பக்கத்தில் யார் இருக்கு? Z இருக்கு. So Z வந்து இப்படி எழுதணும். You have the Z here. You have the Y here. Clear? Clear? புரிஞ்சிருச்சா? Now, I hope that is clear. Now, Soha's projection formula. This is going to be very easy, children. You have your C and Z, A and B, X, Y. Okay? So, how you will write it here? இங்கிருந்து பாருங்க. You have to see from this side. இந்த சைடில் பார்க்கும்போது இந்த கார்பனும் see, ரெண்டுமே ஒட்டுக்கா வந்திருக்கு. இப்படி இருக்கு. Okay? So, now I'm watching from this side. Okay? So, this இப்படி இருக்கு. ரெண்டு சைடில் இப்படி. So, now I'm watching from this side. இங்கிருந்து பார்க்கும்போது this and this red color and yellow color as the longest chain. So this is going to be a longest chain. Which one is going to be longest chain? This is going to be a longest chain. Longest chain will be C will be here and that portion Z will be there. Now why? Now listen. Now இந்த Z consider பண்ணும்போது while I'm looking it here, நான் இங்க மாதிரி பார்க்கும்போது, so this is your A and B. இந்த மாதிரி பார்க்கும்போது B is on the right side, right? So B is on the right side. As per looking from the Zல இருந்து பார்க்கும்போது B is on the right side and A is on the left side. Now, அதுக்கேற்ற மாதிரி என்ன இருக்கும்? Y is on the right side, X is on the left side. As simple as that. புரிஞ்சிருச்சா பசங்களா? புரிஞ்சிருச்சா? Another one. We are almost to the end. You have Z here, X and Y here, and you have your, for example, beta, gamma and alpha. Now you have to change them into the Soha's formula. Listen. First of all, this is, you can do one thing, children. This is separately now. You can change it. Change into the, this is actually not change into the eclipse one. You have to change into the eclipse one. When you change the eclipse one, how it will be? This is having your gamma. So it will be like this. Beta will be like this. This is going to be beta, this is going to be gamma, and it will be, this is going to be your alpha. Correct? It will be same thing. So now you look. So alpha will be on the top, down. Z will be on the top. Beta will be here. Gamma will be here. Y will be here. X will be here. We are just twisting it. இப்படி இருந்தது twist பண்ணிட்டோம். ஸோ ஒரே மாதிரி ஆகிறதுக்கு. ஸோ இது ஒரு தடவை இப்படி இருந்தவங்கள இப்படி twist பண்ணுறோம். ஸோ இந்த பொசிஷனில் இருந்தவங்க இங்கே வருதாங்க. ஓகே. Now, Newman to Fisher projection. And for example, okay, அதுவே வந்து இப்படி கொடுக்குறேன், டிஃப்ரெண்டாக கொடுக்குறேன். A, B and C. And you have your, one second, textbook la irukku, X, Y, Z. Okay, you have your X, Y, Z. Now how will you do this? Try to do it, children. எப்படி பண்ணுவீங்க? You can see that this set and this set, they are in the, just a second. எப்படி பண்ணுவீங்க பசங்களா? C will be here, Z will be here. C consider பண்ணும்போது B is here, A is here, right? Z consider பண்ணும்போது X, Y is here, X is here. That's it. X பார்க்கும்போது Y வந்து right sideல இருக்கு, X வந்து left sideல இருக்கு. Clear? Got it, children? பின்னாடி இருக்கிறது. ஸோ சி டே இது எப்படின்னா இப்படி தான் காமிச்சிருக்காங்க. இது வந்து உங்களோட சரி இப்படி காமிச்சிருக்காங்க. திஸ் இஸ் யோர் சி, திஸ் இஸ் யோர் ஜெட். ஸோ திஸ் இஸ் ஆக்சுவலி ரொம்ப இங்கேருந்து பார்க்கும்போது திஸ் இஸ் த லாங்கஸ்ட் செயின். ஓகே, அதை வச்சு பேஸ் பண்ணி எழுதியிருக்காங்க. கிளியர் எவ்ரிவன்? கிளியர்? ஸோ திஸ் இஸ் கோயிங் டு பி யோர் பர்டிகுலர் நியூமன் டு ஃபிஷர் ப்ரொஜெக்ஷன். இனி வந்து உங்களுக்கு இது பக்கத்தில் எல்லாமே இப்படி கொடுத்துட்டேன்னா யூ ஹாவ் டு டூ இட் இந்த எக்லிப்ஸில் கன்வெர்ட் பண்ணிவிட்டு உங்களுக்கு எழுதலாம். எக்லிப்ஸில் கன்வெர்ட் பண்ணிவிட்டு யூ கேன் ரைட் இட். கிளியர் எவ்ரிவன்? கிளியர்? ஸோ திஸ் இஸ் ஆல் அபவுட் யுவர் ஐசோமரிசம். நம்ம வந்து ஐசோமரிசம் முடிச்சிட்டோங்க. இனி வி ஆர் கோயிங் டு லுக் இன் டு தி ஹைட்ரோகார்பன்ஸ். ஹைட்ரோகார்பன்ஸை பற்றி தான் படிக்க போகிறோம். ஷால் வி டேக் ஃபியூ மினிட்ஸ் ஆஃப் பிரேக் சில்ட்ரன்? டூ மச் எக்ஸாஸ்டட். ஒரே நிமிஷம். hydrocarbons. Shall we take 2 minutes of break? Okay, come by. Not 2 minutes actually. 6:45. Okay, then we can continuously we can take till 8 o'clock. 8:15. Then I will give you some break for the breakfast. I mean dinner. Okay. Hello guys. Hey guys. உங்களுக்கு என்ன பார்க்க முடியாதுன்னு நினைக்கிறேன். I will do it. 1 second. தெரியுதா guys? வந்துட்டீங்களா? வாங்க guys. ஐயோ எனக்கு தலை வலிக்குது. இன்னைக்கு பார்த்து என்னன்னு தெரியல, இப்படி தலை வலிக்குது. வாங்க guys. எனக்கு தலை வலிக்குது. இன்னைக்கு பார்த்து என்னன்னு தெரியல, இப்படி தலை வலிக்குது. ஆரம்பிக்கலாமா? Shall we start our session, children? So we are going to discuss about hydrocarbons. So hydrocarbons, what are the, see, hydrocarbons வந்து பாத்தீங்கன்னா you can say that it is having like they are like alkenes, alkynes இருக்கு. So I'm actually dividing this particular topics hydrocarbons into 3. I mean not 3, 4. You will be having alkanes. We will be discussing about the alkanes and aromatic hydrocarbon. Are you guys there, children? இருக்கீங்களா guys? Okay, so this is all about the chapter. So alkanes and alkenes I will be completing today, probably. Alkenes, alkynes and aromatic hydrocarbons. Now I may take one more class, may not be one more class தேவை இருக்காது. அதிலே நம்ம வந்து இந்த halo alkanes and allorenes முடிக்கிறதுக்கு ட்ரை பண்றேன். Okay, 1 second, children. ஒரு நிமிஷம் பசங்களா. One second, children. One second. You can see me now. Okay, so that is all I'm going to discuss now. Okay, so first of all we are going to discuss about the alkenes. Alkenes are the one, tell me what is alkenes. The general formula of the alkenes is CnH2n plus 2. Correct? CnH2n plus 2 is the general formula of the alkenes. That is something you know that, right? CnH2n, these are the bond length and all, that is not required, children. So general formula is CnH2n plus 2. Okay, so that is the alkane and alkanes or general formula. Any avangaloda general preparations, general method of the preparation of the alkanes oda what are the general methods in order to prepare the alkane? First method is the hydrogenation of unsaturated water, unsaturated compound. Hydrogenation means, what do you mean by hydrogenations? Hydrogenations means dehydrogenation is there, hydrogenations is there. What do you mean by hydrogenation, children? Tell me what is the meaning of the hydrogenation. Hydrogenation of unsaturated compound. Unsaturated compounds means those who have the double bond and the triple bond, right? So hydrogenation means, what do you mean by hydrogenation? Those who are watching, please do tell me in the chat box. Hydrogenation, addition of hydrogen or removal of hydrogen. What do you mean by hydrogenations? The hydrogenation means, if you don't know, please do write down in the side or somewhere. Addition of hydrogen. We are adding the hydrogen to the particular reaction. Okay, addition of hydrogen. For example, if you have a unsaturated compound, okay, you have an unsaturated compound and we are adding the hydrogen into that in the presence of a catalyst or a metal like platinum, palladium, or even nickel also usually, right? Then we will be getting the single bonded hydrogen is added. Okay, so this is in the presence of the platinum or palladium or nickel, hydrogen is added, and that particular reaction is called as the hydrogenation. So this is the first way we can make this particular. Where is Sarvesh? Sarvesh, I told you now I will be taking. Where are you? Are you guys are there? இருக்கீங்களா Sarvesh? Are you there? Sarvesh is there. Those who are there, please do message me in the chat box. Those who are there. Hmm? Okay, so this is actually the first reaction, first one. Okay, next one, even for the triple bond also, which is the YNE also, we will be adding water. But in the case of YNE, we have to add 4 times of water. Then only we will be adding, see, we have to break the 3 bonds, right? We have to break the 3 bonds are there, we have to break the 2 bonds. 2 bonds may break பண்ணனும்னா அங்க 4 molecules, 4 hydrogen atoms கொடுக்கணும். So we have to 2 H2O. In the presence of same one, we will be getting the carbon, hydrogen, here hydrogen. Clear everyone? Clear? This is how this works. For example, if you have the example like CH2 double bond CH2 in the presence of water, in the presence of not water children, hydrogen, in the presence of the nickel, platinum or palladium, we will be getting CH3 single bond CH3. Or else I can give you another example like, okay, CH single bond CH2, CH3. Okay, CH3 single bond CH2, CH3 single bond in the presence of the nickel, platinum or palladium. What we will be getting? We will be getting CH3. Or a nimsham. Sorry. CH3 or CH3 propene in the presence of the same catalyst, we will be getting CH3, CH2, CH3. Clear everyone? Clear? Clear? So this is actually called as the, this is the particular general method, and that's the hydrogenation of unsaturated anavansoda hydrogenations தான் நம்ம படிச்சிட்டோம். புரியுதா பசங்களா? And I want you to know one more thing here. This is actually unsaturated ones, na? So this is actually the syn addition. Okay, syn addition. What do you mean by the syn addition, children? Tell me, what is the syn addition? Syn addition means, for example, syn addition means, listen children, syn addition means, for example, you have a compound like CH3 C triple bond C CH3. Okay, I'm adding 2 molecules. No, I'm just adding 1 molecules of hydrogen, 1 molecules of H2 in the presence of nickel, platinum, palladium. Okay, I'm adding எவ்வளவு molecules? ஒரு molecule of hydrogen H2 தான் add பண்றேன். ஒரு molecules of H2 add பண்றேன். Children, this is very important. If you add 2 moles of H2 only for the alkynes YNE, we will be getting alkanes. Okay, we will be getting the alkane. But when you add for the 3 triple bond, when you add 1 single mole of H2 means you won't be getting the single bond. ட்ரிபிள் பாண்டுக்கு நம்ம ஜஸ்ட் ஒரு ஒன் மோல் ஆஃப் H2 ஆட் இது பண்ணிட்டேன்னா, இல்லை H2 மட்டும் ஆட் பண்ணிட்டேன்னா நமக்கு என்ன கிடைக்காது? we won't be getting the single bond. We will be, instead of that, we will be getting the double bond. And this thing we can write it like this also, right? Correct? Correct? This is actually is your sin. This is your sin. If you are writing this like this is your trans. I hope you remember in the isomerism. This is what I'm telling you. Whenever you are studying, you have to study the isomerism first. So always remember dehydrogenation. When we are adding water, when we are adding hydrogen to the unsaturated compound in the presence of the nickel, palladium or palladium and platinum metals, that is actually undertaking sin addition. Clear, everyone? Clear? Okay, so this is the first one, first hydrogenation of unsaturated alkenes. Now you have the alkyl compounds. This is very important. From alkyl compound, those who are listening, please do take the notes along with me. From alkyl halide, not compounds, alkyl halide. From the alkyl halide, as I see, this is now like this. So they will be having the reaction with the metallic substances, the metals with the metals, and by the reduction also. This reaction now with the Grignard reagent is very important. It's very much important in the chemistry, and with the metals also, metal and acids in the presence of said NHG, and you have this reduction with the LiAlH4. All those things are there that we discussed. So from the metallic substance, we have the Woods reactions, fitting reaction, Woods fitting reaction. These three are very important. Then Ullmann's condensation is there, Franklin reactions is there, Corey-House synthesis is there. So these are the one which is from the alkyl halide. Okay, these are the one which is from the alkyl halide. So first one, shall we look to the first one? Children? What was the first one? Woods reaction. Okay, so first one from the reaction of the metal substance, that is Woods is there, fitting is there, Woods fitting is there. Then you have what else? Ullmann's reactions is there, and Franklin reaction is there, Corey-House is there. Okay, so next one is the reduction. So we can discuss with the metal substance, that is your particular Woods reaction. Okay, Woods reaction means, tell me what is a Woods reaction, children. Those who know, please do put in the chat box. You have to know by this time, right? கொஞ்சமாவது தெரிஞ்சிருக்கணுமே. பார்க்குற மூணு பசங்கள சொல்லுங்க பசங்களா. Alkyl halide in the presence of a sodium metal. Okay, alkyl halide in the presence of the sodium metal, in the presence of the dry ether. When the alkyl halide react with the sodium in the presence of the dry ether, they will give you alkane plus NaX. Here I want to add you one thing. Here 2 moles of Na, 2 Na and 2 Rx. So you will be getting 2 NaX. Clear, children? Clear? And here also I want to tell you one thing. Even number of alkanes, which means I can tell you symmetrical alkanes. This is also very important. Symmetrical alkanes. Okay, symmetrical alkanes we will be using it. Clear, everyone? Clear? So let me ask you one thing, children. Why this is dry ether? Why not it is a cold ether, or why not it is a normal ether, moist ether? What is the reason? Moist ether, what happens means the sodium will react. Am I correct? Sodium will react with the water or H2O in the ether. You know that when sodium will react, it will be creating a explosion. So stop that only. We are using the dry ether. That is also an important point. I guess it is mentioned in the NCERT textbook if I'm not wrong. Okay. So if you have, for example, you have your CH3Br in the presence of the sodium plus in the presence of the dry ether. Okay, now what will be happening? CH3 plus 2 NaBr. You will be getting alkane, which is ethane. You will be getting ethane from this. Clear, everyone? Clear? You will be getting ethane. Or else you can say that if you got CH3 CH2Cl. Okay, CH3 CH2Cl. What is the name of this compound? What is the name of the compound? Method. Ethyl halide, ethyl chloride in the presence of 2Na. Reacting with the 2Na in the presence of either, we will be getting CH3, CH2, CH3. Which means, what is the name of this? Method proper bute. We will be getting butane, which means நம்ம என்ன ஆட் பண்றதோ அது டபுளா கிடைச்சிடும். இங்க வந்து குளோரினும் போய்டும், எண்ணெயும் போய்டும். Okay, so this is all about the ஐயோ ஒரே நிமிஷம். This is all about your Woods reaction. This is all about your Woods reaction. புரியுதா பசங்களா? புரியுதா? Now another example, one more example. For example, you have your CH3, 2 moles of CH3. Okay, CH3, Cl. In the presence of 2Na. The Cl will be taken, 2Na will be precipitating. We are using dry ether as a solvent. What we will be getting? CH3, CH, CH3, then again CH, CH3, CH3. What we will be getting? Then method the proper butane. Clear everyone? Clear? Purida pasangla? Did you need the mechanism of this? This is having the free radical mechanism actually. I will just tell the mechanism also, just for refresh understanding purpose only. This is actually there is actually two mechanism as per this. One is radical mechanism and one is ionic mechanism. You know that when you studied in the particular ionic reactions, and then you have studied about the addition reactions also. So ionic mechanism இருக்கு, radical mechanism இருக்கு. So radical mechanism தான் இதோட கரெக்டான mechanism. இல்லைன்னா ஈஸி வே நமக்கு புரிஞ்சிறதுக்கு radical mechanism தான் it is much more easier way. Okay, so this mechanism is not in the NCERT, my dear students. I'm just telling what is happening there, that's it. Okay, so you know that CH3 CH2 Br in the presence of the sodium, dry ether, this is formed, right? இது மட்டும் இல்லாம இன்னொன்னு ஃபார்ம் பண்ணிருக்காங்க. எதுன்னு தெரியுமா? This is actually 2 moles of this is reacting. இது 2 moles இருக்கு, இது 2 moles இருக்கு. இது சேமா ரியாக்ட் பண்ணும்போது இது இல்லாம இன்னொன்னு ஃபார்ம் ஆயிடும். Do you have any idea, my dear students, how it will be forming? Any idea? Not only that, it will be forming CH3 plus CH2 double bond CH2. This is actually formed by the dissociation. I will tell you how this happens and all. இது வந்து dissociation ஆகுதும், இது வந்து formed as a result of the association. I will tell you what is association and all. Listen. Association. So sodium in the presence of the dry ether. Sodium in the presence of the dry ether, what will be happening? 1 electron. You know that sodium will be giving 1 electron. Am I right, my dear students? Sodium will be giving 1 electron. Now, you have the CH3, CH2, Br. Correct? You have the CH3, CH2, Br. Amadana. And the electron அதை accept பண்ணிட்டேன் என்ன ஆயிடும்? I'm just breaking this bond of this particular Br. இந்த bond நான் break பண்ணிட்டேன். So இப்போ என்ன ஆயிடும் பசங்களா? யோசிச்சு பாருங்க. CH3 இருக்கும், CH2 இருக்கும், இங்க ஒரு bond இருக்கும், அது கூட யார் இருக்கும்? Br இருந்திருக்கும். Br கூட ஒரு bond வந்து ஒரு already ஒரு radical இருக்கு, electrons வந்துருச்சு, which means negative charge ஆயிடும் Br. Am I correct? Already ஒரு radical இருந்தது, இங்க இருந்து ஒரு electron கூட வந்துருச்சு, which means negative charge ஆயிடும். Okay children. Now CH3 CH2 is there, right? So இதே மாதிரி இன்னொரு CH3 CH2 இருக்குல்ல, the 2 moles தான react பண்றாங்க. So they together they will be creating CH3 CH2, CH2, CH3, because this bond and this bond will be joining and they will be creating. So this is actually called as the dissociation. This is actually called as the dissociation. Clear everyone? This is actually called as the dissociation. Now listen carefully. Same CH3 CH2 radical is there, na? Correct? That radical, listen carefully, this is very very important. இங்கே ஒரு radical இருக்கு. ஆமா தானே? Right? Right? Okay, I will write it like this. One second. இது இப்படி தானே CH3 CH2 இருக்கும். என்ன ஆகுறேன்னா இந்த ரெண்டு பாண்ட் இருக்குல்லடா, இந்த ஒரு பாண்டு அது கட் ஆயிடும். அந்த பாண்டு கட் ஆகும்போது சி யூ ஹாவ் எ ரேடிக்கல் ஹியர். இந்த ரேடிக்கல் இங்கே போயிடும். ஓகே, அதே மாதிரி இந்த ரேடிக்கல் இங்கே வந்துடும். வாட் வில் பி ஃபார்மிங் சில்ட்ரன்? இந்த ரேடிக்கல் இருக்குல்ல, திஸ் பர்டிகுலர் ரேடிக்கல் வில் பி கோயிங் ஹியர் ஆல்சோ. clear? So it will be like CH3 CH3. இந்த ரெண்டு ரேடிக்கல் இங்கே இருக்கிற ரேடிக்கல் CH2 ஆயிடுச்சு. ப்ளஸ் CH2 double bond CH2. So this is your, ஐயோ பசங்களா, this is your association. Sorry. One second. Sorry. This is your association. Okay. This is your dissociation. Clear everyone? Clear? Now next one is more important note. Tertiary haloalkanes is not used. இதில் வந்து நம்ம வந்து tertiary haloalkanes யூஸ் பண்ண மாட்டோம். இது நோட்டை எழுதி வச்சுக்கோங்க. They will be asking you, okay? Just as a note you can write down. Note, tertiary haloalkane is not used in the particular Woods reaction. Woods reaction. Woods reaction. Clear everyone? Clear? Clear? Okay. So this is your Woods reaction. Next, this is your Woods reaction, which we have already discussed everything. Now you have your cross-Woods reaction. Cross-Woods reaction. Okay. Cross-Woods reaction. One second, children. Listen. Cross-Woods reaction. ഇതിലേ വേറൊരു topic down. Cross-Woods reaction. Same thing only. See, you will be having here in the presence of sodium bar dry ஆயிடுது. So you will be getting இது ரெண்டுமே join பண்ணிடுவாங்க. எதெல்லாம் join பண்ணிடுவாங்க? Listen carefully. I'll tell you. Listen. Listen carefully. CH3. See, this CH3. Okay. Now a second. ஒரு நிமிஷம். இதில் இருக்கிற ரெண்டு மோல்ஸ் சேர்ந்துருவாங்க. CH3 CH2 CH2 CH3 ப்ளஸ் இதில் இருக்கிற ரெண்டு மோல்ஸ் இருக்குல்ல, CH3 CH3. ஸோ தீஸ் ஆர் ஆக்சுவலி உங்களுக்கு அவங்களே செல்ஃபாக வந்தது. செல்ஃப் ஜாயினிங் தானே இதில் இருக்கிற. you will be having 2 moles of this one. So CH3 CH3 okay, and this will be creating CH3 இதில் இருந்து இன்னொரு மோலிக்யூல் எடுத்து CH3 ஆகிடும். இதில் CH2 எடுத்துகிட்டு இங்கே வந்துடும். ப்ளஸ் க்ரோஸாக ஜாயின் பண்ணிடுவாங்க. இதுவும் ஜாயின் பண்ணிடுவாங்க, which means CH3 CH2 CH3. Okay, so this is your cross product. Clear? And this cross product is your major and self product தான் உங்களோட என்னதாக இருக்கும், மைனராக வரும். புரியுதா பசங்களா? இதில் வர சின்ன ஒரு இக்குவேஷன் தான், சின்ன ஒரு derivation, சின்ன ஒரு particular reactions. Clear everyone, those who are watching? இது வந்து இன்னொரு விஷயம் என்ன சொல்கிறாங்கன்னா, இதில் க்ரோஸ்வுட் ரியாக்ஷனில் டெக்ஸ்ட் புக்கில் கொடுத்துருக்காங்க, they are saying that they have less difference in their boiling point. அவங்களோட பாயிலிங் பாயிண்ட் நார்மல் டெம்பரேச்சரில் தானே நம்ம இதெல்லாம் பண்ண போகிறோம். அவங்களோட பாயிலிங் பாயிண்ட் வந்து ரொம்ப லெஸ்ஸாக இருக்குது. ஸோ அவங்களுக்கு வந்து அந்த பாயிலிங் பாயிண்ட் டிஃப்ரென்ஸ் லெஸ்ஸாக இருக்கிறதுனால தே cannot be separated easily. அவங்க அந்த ஒரு பர்டிகுலர் மெத்தட் ஆஃப் செப்பரேஷன் சொல்கிறது இட்ஸ் நாட் தட் மச் ஈஸி. Clear everyone? Good evening Preeti. If you are children, if you are watching me for the first time, please do subscribe the channel and share this channel to your friends also. Okay, now textbook la illada oru vishayam irukku. First of all, adukku munadi I will discuss about the drawbacks of the Woods reaction oda drawbacks solren. Do you know what are the drawbacks of the Woods reaction, children? Any idea about the what drawbacks? They unsymmetrical compounds ஒண்ணுமே இதலான முடியாது. CH4 சொல்றது it's not prepared by the Woods reaction. Okay, which means it's unsymmetrical compounds வந்து பண்ண முடியாது. That is the first one. Only எது மட்டும்தான் பண்ண முடியும், only even number carbon containing symmetrical alkane, which means symmetrical alkane is prepared by the method. இந்த மெத்தட்னால புரியுதா பசங்களா? அது மட்டும்தான் பண்ண முடியும். This is a very big drawback. Woods reaction ஓட ரொம்ப பெரிய drawback தான் இது. Drawbacks of Woods reaction. புரிஞ்சிருச்சா? Clear everyone? Done? Shall we do an example here, which is actually asked in the NEET question paper. So the question is, which of the following can't be prepared by Woods reaction? N-hexane and butane, 2,3-dimethyl butane, 4N-heptane. Which of the one won't be prepared? Please do tell me who is watching this. இது வந்து நீட்ல கேட்டிருக்காங்கடா. They have asked you in the NEET question paper. Try to do it, children. பண்ணுங்க பசங்களா, பண்ணி பாருங்க. Those who are watching this, please do tell me. ஒரு நிமிஷம், my phone is actually என்னோட phone dead ஆக போகுது. ஒரு நிமிஷம், I will just, if I didn't charge it now, na, it's, I won't be able to see your text. Tell me children, do this question. Try to do this question. எப்படி பண்ணுவீங்க இதில்? டே என் ஹெக்ஸேன் உங்களுக்கே தெரியும், they won't be giving you unsymmetrical. See, symmetrical alkanes மட்டும்தான் கொடுப்பாங்க, unsymmetrical alkanes கொடுக்க மாட்டாங்க. கரெக்ட்? unsymmetrical unsymmetrical இருக்கிறது they won't be giving you. Some unsymmetrical alkanes won't be preparing from them, right? They won't be preparing it, right? Right or wrong, my dear students? Yes. Now hexane. They are carbon irukda. This is a symmetrical one. Inga butane, metheth proper butane, which means 4 carbon, right? This is also a symmetrical one, right? Now this will be giving 2. Inga da neenga doubt பண்ணுவீங்க, ஓ இது வருவானு. இதோட ஸ்டெப் வந்து 1 2 3 4. Okay, second. இங்கேயும் கொடுத்துருக்காங்க, இங்கேயும் கொடுத்துருக்காங்க. இங்க கட் பண்ணலாம்ல, இங்க கட் பண்ணிக்கலாம்ல. This is also a compound, this is also a compound, right? They can do it. So this is also butane சொல்லும்போது 4 symmetrical தான். Heptane, it is 7, it is unsymmetrical. Clear everyone? Clear? So this won't be giving you the particular reaction with the or particular Woods reaction. They won't be giving you the Woods reaction for this. Clear everyone? Those who are watching, is it clear everyone? Please do tell me, is it clear or not? Now, NCERT la illada oru vishayam da, but it's better to note that also. Intramolecular Woods reaction. Intramolecular Woods reaction. It's not in NCERT, but still you can get an idea about it. Paper ரொம்ப difficult இருக்கும்போது இந்த மாதிரி questions எல்லாம் வரலாம். Intramolecular Woods reaction. Okay, so intramolecular Woods reaction means, for example, you have your okay, Cl okay, in the presence of, they're just giving you this only. They are giving you like in the presence of sodium triether. Okay, normal Woods reaction. What is happening here? You know that free radical mechanism. So what happens here is this bond will be breaking and they will be forming the radical. These two will be joining together. புரியுதா? அவங்க ரெண்டு பேருமே ஜாயின் பண்ணிடுவாங்க. So it will be like CH2. They will be creating a structure of like this. Clear everyone? Clear? Now, இது வந்து IIT லெவல்ல கேட்டிருக்கிற ஒரு கொஷின். just ஒரு ஏதோ ஒரு இயர்ல ஜெயில குறிச்ச ஒரு கொஷின்ஸ். 1 second. They ask you just like this question. Okay. This is, what is this, children? You have the butane, right? 2,2-dichloro or cyclobutane, right? Now, when that is reacting with your triether, what will be the formation? What will be forming, children? The bond will be breaking and you will be having a radical here, radical here. That radical, both radical will be joining and they will be creating a compound like this. Am I correct, my dear students? Am I correct? Another one more question also they have given, like, okay. In the presence of dry ether. Okay. So all these are, this is actually they have given you 2 moles. Okay. 2 moles கொடுத்திருக்காங்க. என்ன ஆயிடும் கேக்குறாங்க. What will be happening? Children, between the bromine and chlorine, you know that CCBr is there, CCl is there, the bond. Carbon chlorine, carbon bond, bromine. Carbon bromine bond will be breaking very fastly because they do have the less bond energy, right? Their bond energy is less. So they will be breaking very fastly and they will be forming Cl is there, radical is there. Am I correct? Or radical? This one. Radical is there. That is also 2 moles. Now, 2 moles of radicals are there. Now, what happens means, இதே மாதிரி ஒன்று இருக்கு, which means Cl see, this will be the 2 ones. Okay, clear everyone? புரிஞ்சிருச்சா? So இந்த மாதிரி அவங்க கேட்கறதுக்கு chances இருக்கு. So this is also another example for this. Okay, now you have next topic. So first one is Woods reaction is done. Now second one is fitting reaction. Fitting reaction எப்படி இருப்பீங்க சொல்லுங்க? Fitting reaction எப்படி இருக்கும்? Woods reaction was the 2 moles of alkyl halide. Fitting reaction will be, it's with the aryl halide. It will be with the aryl halide. Okay, that this I guess you will be, yes, you will be studying in the haloalkane again, children. Class 12. Okay, haloalkane and haloarenes, you will be studying this. So you will be having 2 molecules of aryl halide. Okay, in the presence of Na, sodium will be reacting. You will be forming dry ether, and that 2 moles of particular one will give you diphenyl. Clear everyone? Will give you diphenyl. What is they giving, children? Tell me, what are they giving? Diphenyl. That will be giving you diphenyl. Clear? Clear? This is available in your NCERT. Okay. One more there is in the NCERT. Woods fitting reaction. Third one. Woods fitting reaction. Woods reaction la haloalkane, fitting reaction la haloaride. இதுல வந்து ரெண்டுமே யூஸ் பண்ணுவாங்க. For example, you have CH3Cl in the presence of a aryl halide, CH3Cl in the presence of aryl halide. You have the dry ether. What they will be forming? This will be removing, this will be removing. It is like toluene. You got your toluene. Okay, this is actually in your textbook, NCERT textbook. This is this 2 one. Clear? Now next reaction, what was the reaction from the metal carbonates, metal substance, Ullmann reaction? That is not an NCERT, but you have to get an idea about it. Okay, For example, iodobenzene, not this one, not iodobenzene. You have 2 moles of iodobenzene. They are reacting in the presence of sodium dry ether. You will be getting diphenyl, correct? Like rest of the products is not required. Diphenyl. Those who are in the class, please do note it down, children. Diphenyl. This is the fourth one. Next one. I'm having severe headache, children. Severe headache. I don't know what happened. Extreme headache. Now, Franklin reaction. Franklin reaction. Do you know what is Franklin reaction? Tell me. Any idea, my dear students? You have a haloalkane, 2 haloalkanes, okay? 2 haloalkanes in the presence of zinc. When we heat it, we will be getting alkanes. So this is actually basically, I will tell you, it can undergo primary haloalkane, secondary haloalkane, tertiary haloalkanes also. Okay, this is your Franklin reaction, and we will be getting, this is a nice method, this is a good method. Why means we will be getting symmetrical or unsymmetrical alkanes obtained. Formed from this method. Clear? இங்கே இன்னொரு பாயிண்ட் என்னன்னா, இப்போ நமக்கு வந்து இது ரெண்டுமே சேமாகவும் இருக்கலாம், இது ரெண்டுமே டிஃப்ரெண்டாகவும் இருக்கலாம். இட் கேன் பி சேம். ஆர் அண்ட் ஆர் டேஷ் கேன் பி, சி ஆர் அண்ட் ஆர் டேஷ் கேன் பி சேம். R and R dash can be different also. So that is why we can get a symmetrical one and unsymmetrical one also. There is a chance of getting both. Clear? Clear everyone? Clear? Next very important reaction. Is, did you done with this? Copied? Copy it down, children. Copy it down. Copy it பசங்களா? Shall we move to the next one? Next one is Corey House. Corey House synthesis. Okay. Corey House synthesis. Do you know what it is? See, Corey House synthesis is here, children. second. Curry house synthesis. Okay, I'll tell you what it is exactly. Curry house synthesis. In the presence of a alkyl halide. So see, first of all, alkenes prepare பண்றது நம்ம first நம்ம என்ன பார்த்துட்டு இருந்தோம்னா, we are discussing about the halo alkenes. Halo alkenes இருந்து எப்படி கிடைக்கிறது, அதுக்கப்புறம் halo alkenesல இருந்து, அப்புறம் ஆல்கஹால்ல இருந்து, அப்புறம் ஆசிட்ல இருந்து, அதே போல அமைட்ல இருந்து, இதெல்லாம் தான் நம்ம டிஸ்கஸ் பண்ண போறோம். ஓகே, ஸோ we will be discussing about the alkenes எப்படி வந்து halo alkane இருந்து கிடைக்குது, அப்புறம் alkenes வந்து எப்படி ஆல்கஹால்ல இருந்து கிடைக்குது. These are the things which we are going to discuss. Okay, so that's why I'm just all the equations which is related to halo alkanes are I'm telling as a ஒரு கனெக்ஷனாக சொல்கிறேன். அப்போ உங்களுக்கு வந்து ஹாலோ ஆல்கேன்ஸ் வந்து கிடைக்கிறது அதுக்கு Woods reaction, Woods fitting reactions, you have your Ullmann reaction, Franklin reactions, Corey house reaction. You can easily உங்களுக்கு வந்து அந்த ஸ்டெப்பாக கிடைக்கும். புரியுதா? Okay, so Rx is there, halo alkane is there in the presence of, this is very important children, 1 second. ஐயோ தலை வலிக்குது. In the presence of lithium Li ether, secondly copper iodide, third followed by the another alkyl halide. This is very important. That particular alkyl halide can be primary, can be secondary also, but not tertiary. I'll tell you what it is, why it is. Okay, so then we will be getting a alkane which can be symmetry or unsymmetry also. Symmetry agla, unsymmetry agla. சரிங்களா? So ஏன் இது இப்படி வருது? Any idea? Tertiary is not possible. Tertiary halo alkane is not possible. They won't be. I'll tell you what it is happening here. You have your halo alkane and they will be acting with the lithium. This is not the balanced one. Okay, that is not required also. Lithium in the presence of the ether, you will be getting Rli plus Cu, not Cu, Rli plus Lix. Actually, there is 4 moles of lithium is using actually. And you will be getting 2 moles of Rli plus and Lix. Okay, so this 2 moles of Rli will be reacting with your copper iodide. And they will be creating a bond. Did you remember this one? You know what is this? Gilman reaction. R2LiCu. Sorry, R2LiCu plus lithium iodide. This is your Gilman's reagent. What is it, children? This is your Gilman's reagent. Reagent. Gilman reagent. Clear everyone? Clear? Now, in the R2 இருக்குல்ல, இதெல்லாம் உங்களுக்கு தேவையில்லை, but I'm telling you why it is not possible. R2LiCu, that will be reacting with your R-X. Now what will be happening? They will be creating alkane. Okay, so what happens means this will be acting as, இது வந்து என்ன பண்ணுவாங்க, R minus கொடுத்து இங்க வந்து react பண்ணிடுவாங்க electrophile. So what electrophile கிட்ட react பண்ணுவாங்க, which means SN2 mechanism is following. SN2 mechanism. This is a nucleophile. They are acting on the electrophile. So nucleophilic substitution reaction is happening. And if it is a tertiary group means, tertiary group irundha adu ennada irukum? You remember, if it is a bulky group, they will be going to the elimination reaction. Correct? They will be changed into the E2 reaction. SN2 reaction la irundhu they will be changing into the E2 reaction. This R minus will be coming because lithium LiCu will be on the plus charge, right? So it will be coming as R minus. they will be reacting and they will be forming this. Why it is not forming means இது வந்து tertiary ஆயிட்டேனா they will be converting into the, that is actually bulky group. Bulky group இருந்தேனா it is a possibility of forming the elimination E2 வந்துரும். Okay, clear everyone? Now we are going to look into the reduction ones. So this is all about your particular sodium, metals vechittu nama padichadu. Okay, now ipo main ana second main point, reduction. Alkyl halides ne vandu nama vandu first of all alkyl halides la irundhu nama enna pannitom, metal organic metal substance vechu react பண்றதா இருந்தது. இது இப்போ reduction of alkyl halide. Alkyl halide react reduction பண்ணிட்டேன்னா நம்மளால என்ன பண்ண முடியும், we will be getting haloalkane, we will be getting alkanes. Okay, so first one is reduction by using the Grignard reagent. Grignard reagent, reduction by using the Grignard, sorry. Some textbook now they will be giving like GRA, NA, Grignard's reagent. Okay, Grignard's reagent. So do you know how it will be forming? First of all, Grignard reagent எப்படி form ஆயிடும் பசங்களா? Haloalkane, when they react with the main Mg in the presence of dry ether, correct, they will be forming RMgX, correct? Right or wrong, my dear students? Those who are watching, please do tell me. This is your Grignard reagent, right? Correct? This is your Grignard reagent, right? This is very important. Please do listen carefully. Okay? Very important one. You can giving double star in this. So this RMgX, formed RMgX is there, no? When they react with the acidic hydrogen, they will be forming the haloalkanes. Clear? Acidic hydrogen solrabodhu in the presence of H2, acidic hydrogen water irukkalam. Acidic hydrogen solradhu the hydrogen which is attached to the electronegative atom, or which is attached to the electronegative atom, which is the electronegativity is more than 3 basically. 3 க்கு மேல இருக்கிற வேல்யூ வர electronegative atomல பக்கத்துல இருக்கிற ஹைட்ரஜன் எல்லாமே acidic hydrogen தான். வாட்டரா இருக்கட்டும், you have your alcohols, then you have your particular phenol, then what next, acid, then aniline, இது எல்லாமே அசிட்டிக் ஹைட்ரஜன் தான். ஓகே, நார்மல் HX இது அசிட்டிக் ஹைட்ரஜன், அண்ட் இது அசிட்டிக் ஹைட்ரஜன் தான். ஓகே, these are all acidic hydrogens. Okay, you have the ammonia, primary secondary all these are with hydrogen, which is all these are acidic hydrogen. Okay, so this is what happening here. Now listen to me, listen to this. One second, I will add a slide here. Okay, one, listen carefully. Haloalkane, sir, correct, in the presence of Mg, magnesium, ether. Okay, Mg bar ether. Haloalkanes in the presence of Mg bar ether, you will be getting this particular ethyl chloride in the presence of this particular Mg bar here, followed by the water, addition of the water, you will be getting the particular ethane. So do you know what is actually happening here? When they react with the Mg in the presence of ether, they are forming, you remember this one, right? ஞாபகம் இருக்கா guys? they will be forming MgCl, right? This is your Grignard reagent, children. இந்த Grignard reagentக்கு water add பண்ணும்போது, correct? Water add பண்ணும்போது என்ன ஆயிடும்? Water add பண்ணும்போது தான் you will be, that particular MgCl will be leaving and hydrogen will be adding, right? And this will be H plus வந்து இங்க வந்து join பண்ணிடும் plus MgClOH ஆயிடும், correct? This is what happens, right? Correct? Right? So next one more thing. இப்போ உங்களுக்கு வந்து இன்னொன்று, okay, in the presence of magnesium ether or dry ether, magnesium dry ether followed by the water, what will be forming, children? Put in the chat box what will be forming. Okay, instead of that I'm giving you another idea. D2O, deuterium. So CH3 CH2 CH3 இங்க வந்து D வந்துடும். Am I right? இதோட mechanism போய் பாருங்க GOC2ல இருக்கு. Okay, so this will be like, I can tell that magnesium in the presence of the dry ether, they will be creating CH3 CH2 CH CH3 with here இங்க என்ன வந்துடும்? Mg Br வந்துடும், correct? அதிலிருந்து வாட்டர் ஆட் பண்ணும் D2O ஆட் பண்ணும்போது இப்படி வந்துடும். Clear everyone? Clear? And here I want you to say one more thing. 1, 2. These are particularly chiral carbon. So they will be giving you two types of products also, right? They will be giving you two types of destro and levo. That is also there. Okay, that is also very important, children. Clear? Now this is a question, children. Please do the question. Find the product. Find the product obtained by the phenyl magnesium chloride. Phenyl magnesium chloride, not chloride, they have given you iodide. Reflex with methanol. Oh, methanol கொடுத்திருக்காங்க. Methanol கொடுத்திருக்காங்க. You have to, methanol means, see, same thing only, acidic hydrogen only. They have given you the options. Benzene, phenol, or CH3, CH2I. Please do try to do this question. Try to do this question, children. எப்படி பண்ணுவீங்க? Phenyl magnesium iodide in the presence of methyl. See, you have the phenyl magnesium iodide. What is that? Phenyl, that is phenyl MgI. in the presence of CH3OH means this is an acidic hydrogen. They will give you acidic hydrogen. So they already given you இது வச்சு நம்ம வந்து ஆல்ரெடி வந்து இட் வாஸ் ஆக்சுவலி இன் த ஃபார்ம் ஆஃப் தி சம் அதர் ப்ராடக்ட். அதுலேருந்து நம்ம வந்து கிரிகன் ரியாக்ஷன் கிடச்சிருச்சு. அதிக ஹைட்ரஜன் வாட்டருக்கு இன்ஸ்டெட் ஆஃப் வாட்டர் வி ஆர் ஆடிங் மெத்தனால் பிகாஸ் ஹைட்ரஜன் அசிடிக் ஹைட்ரஜன் இஸ் வெரி இம்பார்ட்டன்ட், ரைட்? ஹைட்ரஜன். நவ் இப்போ என்ன பண்ணுவீங்க? வாட் வில் பி ஃபார்மிங் திஸ் MgI வில் பி டேக்கிங். இது மொத்தமாக எடுக்கிற மாதிரி இது மொத்தமாக எடுத்துரும். ஹைட்ரஜன் ஆட் ஆகிடும், கரெக்ட்? ஆர் ஹைட்ரஜன் ஜஸ்ட் இப்படி எழுதினாலே போதும். ப்ளஸ் correct? So benzene will be formed. Benzene will be formed. Clear, children? Benzene will be formed. Children, actually you have the next topic as reduction with the metal and acids, okay? But I'm not longer able to take this because it's maybe like I'm having cold also, so I cannot open my eyes. I'm having that much pain, that much headache, so I'm not able to open my eyes also. So I will be continuing this session in the coming Saturday, which is today is actually 20th November, right? So you will be getting the session again in the 22 November. So by that time I will complete this hydrocarbons, everything, okay? So in a session we will complete it everything, okay? That is probably in the Saturday, because today I'm not able to continue it. I'm not able to I cannot. The thing is actually எனக்கு வந்து யோசிக்க கூட முடிய மாட்டேங்குது இதில் என்ன வரும். நான் அப்படியே ஏதோ ஒரு இதில் இருக்கேன். ஸோ ஐ ஜஸ்ட் வாண்ட் டு கோ டு தி ஹாஸ்பிட்டல் ஆர் எல்ஸ் இட் வில் பி லைக் ஐம் ஹேவிங் சிவியர் ஹெட்டேக். Okay, so we can see on the next class. Okay students, so hope you enjoy. I hope you able to follow this everything. Tomorrow I will be taking again the sessions. Don't worry about it, we will take it again. So like all the sessions we will be continuing it. Like hydrocarbons மொத்தமா நம்ம வந்து Saturday வந்து முடிக்கலாம். So I thought of doing the haloalkanes also in the Saturday itself, but it's not possible. I'm not at all feeling well. So hope you find the session helpful. If you find the session helpful, please do share it with your friends also. And இது மாதிரி இருக்கிற see I am planning a lot of things for you guys children. So உங்களுக்கு live marathons எல்லாமே இருக்கும். So please do subscribe for the channel for the latest updates, everything. And also like in the organic or the முடிஞ்சாலே like I am planning in another lot of things also. Don't worry, we will crack organic. Okay, so hope you find this video useful. Stay tuned, stay happy, stay healthy. படிச்சுக்கோங்க நல்லா, ஓகேங்களா? ஓகே, bye bye.